We're live. Hello, everybody. Hello, hello. Welcome to the stream. Look at the lambda. It's nice, ain't it? Let me make sure. Okay, I can hear myself. We're good. We are good. Let's make our official announcement on our Discord. Let me pause this as well so I don't have to watch my own stream. Perfect. And we are live on twitch.tv/Lenzor. We're live. Compiler. Implementing pointers, hopefully. Part 18. As you can see, we're going to be working on pointers today. And yeah, that's going to be a little bit of a thing. Oh, you know what I forgot to do? I forgot to @ notifs. Let me just sweep in here. Pretend like that didn't happen. Alrighty, how's everybody going? We should get right into it, I think. Streamer 2022 from compiler. Source main. Get our language server up and running. This is good. How is everybody doing today? Ooh. Okie dokie. This is our compiler. So what we would like to do is set up our compile command so that we don't have to do this again. We want to build the debug directory. We want to run the generated executable. And then we want to, let's see, what do we do from there? We need to pass in, if we just do this, it's in the wrong spot. So if I do it from here, so I'm in this directory now, and I'd like to run this from here. That should work. Perfect. And our compiler says, hey, you used us wrong. So as you can see, we say usage, debug/func, but then flags, options, path to file to compile. So we probably just need a file to compile. Don't you love when you forget how to use your own compiler? What is LTX image? I don't know what this is. Suspicion. Debug func. And we would like to pass it. Let's do simple math or conditional. Ooh, let's do factorial. We had a factorial implementation, that's right. And then let's do it verbose with -v or -- verbose. And look at that. So let's go find fact. So this program gets compiled into this AST with a function, takes in n, which is an integer, returns an integer, does a whole bunch of stuff. There's a function call to factorial with 4. That's exactly what we have. And there's a recursive call in here. And you see it generated code at output file path code.s. So if we go check out code.s, we can see that, in fact, there is the factorial function right here. Here, I can indent all this. Here's the factorial function. And then we have main, and main just sets up, we basically just move 4 into racks, we push racks, and then we call factorial. Not bad, not bad. So then this call factorial will jump up here, we'll do our function entry, then we'll do an if n is less than 2, with this compare, cmove conditional move if less than, this backwards instruction, gotta love it. So if R11 is less than RBX, then this is true. So you kind of have to read it backwards, like n is less than 2, not n is less than 2, which we conflagrated those two many a time. Assembly syntax is hard, knowing which way each instruction goes, because it's different. In any case, we test our if condition. If it's 0, we jump to the otherwise. If it's not 0, we fall through to the then, and then jump after the otherwise, I would presume. Yeah, to the function end. Cool. Very cool. Okay, this is starting to make sense. Ooh, my internet took a dip there, sorry. Hopefully everything is fine. In any case, what we would like to do today is point to things, right? Oh boy. So we would want an integer. Let's just choose this syntax. I haven't really decided. An integer pointer, right? So a is an integer pointer. So a should be able to be Mr. Mugame says pointers? Pog. How's it going, Mr. Mugame? It's so great to see you. Ooh, the internet is faulty. It's dropping down my bitrate, even though I'm on a low bitrate already. Mr. Mugame says that syntax is awful. I'm sorry. What's a better one? I just came up with this. Should we do this? I don't want to use multiplication. We're not using the multiplication operator. We can't do that. I almost want at for dereference and this for pointer. But if you have multiple pointers, I mean, this will work. You can have an integer pointer, 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 pointer. What would you recommend? You can only say it's awful if you have an alternative. So if a is an integer, and then we have pointer, which is an integer pointer, or some syntax that Mr. Mugame has for us. Quote integer. Why in front? And what about like this? A pointer to pointer to pointer to pointer. Is that okay? Are you okay with this syntax? We can do this syntax, it's fine. It really doesn't matter, and we can support multiple. Like there's no reason we couldn't have a pointer like this, right? And have a pointer to pointer to pointer to integer. Mr. Mugame says that could be a hassle with strings and chars. Yeah, it would definitely be a problem. We could use backtick. What about backtick? Okay, that's not bad. What about backtick, Mr. Mugame? How about backtick? Tick, 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 tick. Integer. So like I don't know if you have this. It's that character. I typed it in chat so you can copy and paste it if you need. But it's where the tilde goes, like to the left of the 1 on an American QWERTY keyboard. We could use backtick. What do they call it? Grave over there? Grave accent? I don't even remember. So the idea, what should address of be? Maybe address of should be and, like normal. How do we feel about and for address of? So we got backtick for pointer. We have and for address of. I guess that's wrong. We need address of A, right? So pointer can point to an integer, A, like this. Yes? Valid. Valid. I see no complaints. I see no complaints. Or they're typing them up. They're whipping them up, and they're going to be a paragraph of this syntax was awful. It's okay. We can always change it and fix it. So then we need some way to say like the pointer is dereferenced. So at pointer, maybe we do like 4, and then we return A. So this should set A. Here, we'll just do this. So A starts at 0. And then we create a pointer to an integer variable. we assign it to the address of A. I almost want to use @ for address, but I don't want to use and for dereference. Or $sign or hash. What about bang for dereference? Bang, bang, bang. I don't know. That's not too bad. But @ is kind of more clear, I feel like, because that's literally @ pointer, right? This. It's kind of more readable. Ah, bike shedding. Gotta love bike shedding. Maconate, how's it going? Hi, Lens, and hi, chat. How's it going, Mr. Mugame? How's it going, Maconate? What brings you into today's stream? I am happy you are tuning in. So hopefully this will work, I guess. Type is not found in environment. Perfect. And the type is integer. We should really print the error and then not this stuff. But this stuff is useful for debugging, so it's a catch-22. Type not found, pointer to integer. So we gotta work on this. By the way, let me know if this like isn't typable on other keyboards, on like ISO keyboards, because that would suck. I don't want to choose something that's not easily typable. Yes, so we would like to start editing source code of our parser and we're also going to need a new type. Okay, so I think how we're going to do this, I think I wrote a little bit about this actually. I did. Mr. Mugame says, it's like the caret there. You have to do caret plus space to type it. Caret plus space to type this? You have like keyboard macros to type other symbols? The world is much more complicated than I ever knew. So what symbols can be typed on most keyboards? So I don't want alt codes. I just want common symbols. Ah. Mr. Mugame says, for the backtick plus space. Makonate says, today I saw your 7-hour stream from Sunday, and now live stream. That's correct. You made it, Makonate. I'm so happy you tuned in. A lot of people have been tuning into the YouTube. It's crazy. I did not expect that. So for the backtick, you have to write. So for me, I don't know if this is how it's showing up for you. You may be typing this differently or seeing this differently. This is your message, TTV at Mr. Mugame. So you're saying backtick plus space. This is the backtick. So to type backtick, you have to like press it and then something else shows up. So like it'd be like that. And then you press space and that converts it into that. Is that what you're describing? So it's like an extra indirection that you have to type. That's not nice. On US keyboard, we have a key where we just hold shift and press it. And we get tilde, and if you don't hold shift and press it, you get the backtick. If that makes sense. And it's right to the left of the 1, the number 1 above the QWERTY. Mr. Mugame says, caret, backtick are special keys because you got like French accent stuff, and that's why it's like a control key. I see. So by pressing that key and then E, you end up with an accented E. I'm starting to get it now. So backtick plus space means that you basically, it's like I'm telling you to enter control here. Like, oh, to make a pointer, just say control integer. That doesn't really work. I see what you're saying. So don't use the accent symbol that I have on my keyboard. Use a symbol that we all have on all of our keyboards. This gets difficult, you know? What about comma? We all have commas and periods. Question mark? This is hard. We could do pointers like that, but I think that's ugly. It would also, well, I guess that would be fine. We could do angle brackets. Mr. Mugme says, and to not get a character like E, you have to go to space and just get the backtick. Nice, okay. I see, I'm getting it now. I'm getting it now. So we don't have a syntax yet, which is troublesome because we're trying to start at parsing. So we're gonna have a pointer type. Contains one child, which is either variable access. No. It's gonna contain basically a type symbol or another pointer. Yes, because this pointer is just going to be used as like a type thing. In the AST, we're never actually going to create pointer. It's just going to be a type that is type checked. Because we are going to have some new operators, which are unary operators, but I think we're going to implement them specifically. We're going to not do something like this. Well, maybe we should do something like this. Should we do a then we have to have a list of unary operators and prefix and postfix, and let's just do we'll just do it. There's no reason not to do the work. It's not like we don't have time today. Okay. Unary prefix operator, binary infix operator. Sure. So for unary operators, we would like a symbol of the operator itself, but then we would like to store its precedence. I don't think unary operators have precedence, do they? I don't think unary operators have precedence. Because unary operators should just be executed as an expression. Let me think about this. If we had a pointer and we dereference it, see, I'm doing C syntax. So we still have to figure out our syntax. All right. We have to figure out what syntax we want. I don't know. Caret, hash. Add is for dereference, but at could also be for creating the type. We could use something crazy, like put it in parentheses. And however many parentheses it's in, that's how many levels of pointer and direction you have. We could use exclamation point. Chat, if you like one of these, let me know. I have no preference. I just am excited. So if we have pointer plus 3 and we dereference it, we would just like to have this as an expression plus this. But if we were to do like 4 times that, it's the same thing. We wouldn't want to parse like this above a binary operator ever. Or another unary operator. Like if we had and at, these should probably just cancel each other out in optimization stage. But in either case, and at seems like you would just want to apply the and, which is how ASTs work, because we'll see the and, create a node of address of, parse the next one into its child, we'll parse a unary operator at, and we'll parse another another null denotation. These are all null denotations, but this is not a unary operator. And we'll parse a variable access, right? So the dereference will have a variable access, child. That makes sense to me. I would use at as the star and as the and, if you know what I mean. Yeah, we are. I think that syntax has been cemented. So a pointer, to get the address, like to get a pointer from a variable, we're going to use the and ampersand address of operator. But to create a pointer, I still don't know what to do. We could do and the same way, but that's kind of confusing. I don't know. But yeah, at pointer is going to dereference this pointer and get us a. Alrighty. Mr. Mugume says add integer. I mean, I don't mind. That's the same way they do it in C, where they have the dereference the same as the pointer one. Not the worst. Most of the time it's just going to be a single one. Pointer is a point, or you see what I mean? Putter is a pointer to integer. That's not bad. That's not bad. So we're not going to need precedence, it doesn't seem like. Then we have symbol, left-hand side and right-hand side type. See, I don't think this is going to be the same thing. We're going to have to handle these unary operators very specifically, because we're not going to have a left-hand side type of one thing. It's going to either be a pointer and such like that. We're also going to have to change binary operators if we want more complicated ones. But for now, we're just going to implement them directly in the language. So we're going to need, instead of unary operator, we're going to go with address of and dereference. Okay, so with address of and dereference, that should be all we need. We should just need address of operator on a variable access, or dereference operator on a variable access. And then we're also going to have to do this. Parsing types is going to have to change. In variable declarations. Okay. This seems doable. Everything seems doable. I'm going to drink some water, and then we are going to get started. Did anybody notice the parser is like over 1,000 lines already? I thought it was a small parser, then I looked at it on GitHub. I was like, oh shit. Woo! Okay, so when we're parsing, we don't need that. Man, my stomach hurts. When we're parsing, there's some sort of type look ahead that we do for variable declarations. So let's try and find that. So we look for a colon. Oh, this is return type of a function. That's wrong. We look for a colon. I always do that. And after finding a colon after an unknown symbol, we look for a reassignment already. Those are reassignments, totally valid. And then here we have a variable declaration, and here's the invalid type message. Okay. Alrighty. So we say type symbol is the symbol from the current token. Type value is node allocate. And then we say parse get type into type value. And basically just ensure that type value is not null. that it's actually some valid type. And that's currently the error we see. Oh, nope, now we get asserts because of our asserts. So we assert that node type max is equal to 11, but we just added address of and dereference. So it's now going to be 13. We're going to have two new things to... Hey, look, my phone isn't on silent. Gotta love the reminder. Alrighty. So we would like to add some more things, which is dereference and address of. I don't think that's too insane. And then we're going to need node type max once more. In node compare, don't think we're going to be comparing anything like that. Also, did I add 3 because I added pointer, so there's going to be 14, and this still isn't going to work? I'm pretty sure that's how that's going to work. Also, I should really change this node compare function. Yeah, it's still not 13, it's 14. We're probably going to have to write this today, because we're going to be comparing pointers for type comparison. Or we'll just write a custom type comparison thing. So this can now be 14. 14, and then add a pointer. Alrighty. So now we have new types. We're getting there, but type is not found in environment at integer. Alrighty. So now the question comes, type is not found. So that's parse get type. So this just gets the type by a symbol. Okay. So all we would have to do is effectively just say we have a node pointer working result equals result, right? And then we're going to say while, I guess, ID value symbol at 0 is equal to the at, right? We're going to do it. Then we're going to say working result equals. So here's the thing. We have to write into result. So we want to say working result type equals pointer. And then we want to say ID. So we're going to need a char pointer ID it. So this we can put here. Just dereference it and then say ID it plus plus. We could probably put the plus plus in here, but it doesn't matter. So while it equals at, working result type equals pointer, then we're going to say node pointer child equals node allocate, working result children is equal to child, working result equals child. Okay, so this little ditty, we create a pointer, we set the current node to a pointer, I should say, then we create a child and get the type into that and continue. And eventually we'll end up with working result set to some pointer that we can then fill with a type from a type symbol. And then otherwise, we didn't find it. Type not found, ID value symbol. Perfect. Type not found at integer. Okay. So then we have to use this ID iterator as the beginning. Hey, Eternal Wild Fox, good afternoon. How are you doing, Eternal? I saw you were already on to working on a way more complicated project, as you do. So fast, you're like, yeah, I'm making a bytecode compiler and a VM, you know, just simple stuff. It's so awesome. But yeah, how are you, Eternal? It is a good afternoon, I presume. Doing fine, what about you? Thanks for asking, Eternal. I'm doing okay. I don't know if you saw, but there's been a crazy amount of things happening in the on the YouTube. I got like almost 2,000 views. I've gotten a 1,500 in overnight. It's insanity. And it scares me. Why are people watching? What are people watching? Like, you really just watched a dude code for 3 hours? What? But yeah, it's really exciting, and I'm so happy people are enjoying the content. So 1,797 views in the last 48 hours. Woo! Eternal Wild Fox says, nice. That's very nice. It's all thanks to you. If it weren't for you, I wouldn't be doing this. Nobody watched. Symbol and A. So we now don't parse the unary operators address of and dereference. But it seems like this is working. In any case, we now would like to what? We'd like to parse address of. So we not handle stack operator, parse expression. So yeah, we get this symbol, and if the symbol is an at, right? This should be a dereference. I don't know what I just wrote. So if the string compare of at and this symbol that we just parsed is an at, then we should do a dereference. So we're just going to say working result type equals dereference. Working result children equals node allocate child. We're going to do it this way. And then we're going to say working result is equal to the child and continue. So we basically create a dereference node and then parse into its child. Oh boy, more code copy and pasted from Eternal Wild Fox. These are always fun. Let's do it. Session 3. Node.c or whatever. Oh, I gotta regain consciousness. There we go. I wish I had automatic indenting. Alrighty. Node. Int len equals 2 times strlen of node 1, 2, 3, 4, 5, 6. 12, so 14 plus strlen of node data plus size of node child. Is node data a string? I don't think node data is a string, unless you changed it. I thought node symbol was a string. And then you say size of node child plus 2. I'm not sure what this math is. I think you're trying to calculate the length of a string by hand, which is very difficult. Size of is, this is incorrect. The size of len will give you the size of an integer. So 4 bytes. This will return 4. You'll return 4 bytes for the string. Eternal Wild Fox says, I am writing some test code, lol. Yeah, this it's not quite there, but you do have it right. So line will just spit out, yeah, that's fine. That's the current line number. That's pretty cool. But you cannot, I don't think you can do this. Like there's no string concatenation. You can't add a string to a string in C, right? And this is just a string. So you need a comma here instead of a plus. You need no size of, because you don't want the size of an integer. You just want the value of lang. So just pass in lang, right? And then, oh god, yeah, we'll get there. Then you sn printf, which means only write this amount of bytes into this string. So string, so your 4-byte buffer that you allocated, you then write into a lot of bytes. And you try and format some stuff into it with kind of a recursive pair, almost. This is a recursive pair, is what it looks like. It's very cool. So it looks like Eternal Wild Fox, that's also very wrong. Why are you using size of? What's size of for in your head, right? Because size of returns byte width of the type of the given variable or the given type, right? So you can do like size of int length would equal size of int, or size of len. Eternal Wild Fox says it works, lol. Just because it works doesn't mean there's not memory errors. You're allocating 4 bytes, then doing heap allocation, then writing way past 4 bytes. It's very wrong. Just because you put a null terminator somewhere in the heap that doesn't belong to you, and you're able to iterate over the heap until you get to it, that doesn't mean you own the memory. It may be overwritten at any time by the OS, or by your own program, or by another program, or by anything, right? So you do have memory errors. Saying it works, lol, is not something, it's not an argument in C. This is still just a problem. Because this is the length of an integer. So this is always 4. You just said allocate 4 bytes. He says, why is this wrong? I can't believe you don't know. What type is node? What's the type of node? Please tell me, Eternal Wild Fox. Please. What's the type of node? Struct. No. Struct node pointer. It's not a struct. That's part of a type, but it's not a type. You can't just say struct A, right? That's not a type. This is an incomplete type. Struct has a name, so you have a structure, which is a node, but you don't just have that, you have a pointer to that. So what's the size of a pointer? That's 4 bytes still, buddy. You're still getting 4 bytes here, no matter what. The type of node is still pointer, it's 4. You just need to allocate the amount of bytes that are in your string. Bytes in string, right? I'm not sure why you're using the size of node, the size of operator, to get the size of types that you don't need, and strlang doesn't work on anything but strings, so this is wrong, right? And I'm not sure what this is. This looks like custom. The whole point of snprintf is you don't have to worry about this, the length of the buffer. Oh Christ. You would be better off just writing 1,000 here. Just write 1,000 and get rid of this. Boom, it works. Okay? In mine test, node data is a string. Okay, then that would still work. You should still do null checking, otherwise this may return a negative number and screw things up. Or 0, depending on what platform you're on. So why do you have size of node child? What is this? Node child is another node pointer, so this is 4 bytes. What are these 4 bytes for? I'm confused. Right? It doesn't make sense. The length here, let me show you something. Via printf with null or something. Alrighty. Eternal Wildfox says, me too. He's confused as well. So to get the string length that you need, don't you already have this format string? No? So what you can do is use this VSN printf, right? I think you can just use sn printf with a null argument. Let's see. Yes, that's how to use printf. There's got to be, I remember one of them. So get length of format string. Okay, what do we get? I remember doing this. I was able to get, I use it in light all the time. Let's just go look at light. Arusia says pointers usually 8 bytes nowadays. Yeah, it depends if you actually use them or not. It's compiler optimization is heavy in C. Let's just go look at my light, because I know how light works. And there's I'm pretty sure it's in types. Anytime. Oh, I probably have to kill ClangD. It's frozen. I hate ClangD. The only one that works on Windows, but I hate ClangD. So I think somewhere in here, yeah, see format buffer size. So use this. You can use VSN printf. Hey, look, I was right. With a null string argument, and it returns how many, you basically just have to write this, right? Arusia says size of void pointer is unaffected by compiler optimization. I'm pretty sure that you can get 4-byte pointers in 64-bit programs. I may be wrong. Mr. Mugume says, the fuck is this? You can't even pronounce that. Whoever named those standard library functions was like mad drunk. Absolutely. This stands for vector arguments, string, n amount of bytes, print formatted. So there is some sense to it. It just should be written like this. Vector, string, bytes. Or like byte num or something like that, right? But they just chose VSN. Eternal Wild Fox says, but the toString. At least I used assert after malloc. Yeah, that's true. That's pretty good. That's way better. So basically just call VSN printf, right? Do this little thing. Because then you can just say, however large this is, this, right? This will return an integer on how many bytes that string will be. So then you could just do len and always do +1 for the null terminator that you cannot forget. So hopefully something like that could help you, right? And you could even like make this VA list and use VSN printf here as well. You could make the VA list in this function. It wouldn't really matter, right? Arusius says you can compile with -M32 to compile a 32-bit program with 4-byte pointers. I'm fairly certain I've done pointer math in 64-bit programs and it's been 4 bytes. Because I'm pretty sure if all you do are near calls, you don't need any far calls. Then it's, it may have been in freestanding, but I'm pretty sure. Or I'm just incorrect. I could be very wrong. But Eternal Wild Fox, you're right. You're making progress. You're getting more complicated with what you're doing. But to get the length of a format string after it's been formatted, you can use this little ditty. Oh, hey, look, we already do +1. We don't have to do it. Hopefully that helps. If you want, I can print this in the So you'd think this would say it. Whatever. In any case, definitely don't try and calculate the length of format strings by hand. Okay? not something you should do. Always use the same type of function that you're going to use to do the formatting. If that makes sense. Because the printf implementation, it may write strings surrounded by double quotes. So then your little length calculation entirely breaks because the double quotes aren't taken into account. So using the same functions that you use to write into the buffer or do the formatting to get the format string length is the smartest thing to do, I would say. Hopefully that helps. And we can move back to here, where we have invalid syntax, unknown symbol, and A. So I think the idea, Eternal Wild Fox says, yes, thanks, of course, of course. I'm here to fix memory errors. So the idea would be if we have a variable declaration, no, a variable access, then we should look for an amount of address of or dereference operators, but I feel like we should just look for address of or dereference, then get variable access, like this. So let's look for address of in this same way, like literally just the same way. Still symbol and A, unknown. So we're going to have to make it a delimiter of and, so that we get it as by itself. ID of undeclared variable at pointer. So we're going to need at to be a thing. Type not found at. Hey, look, we have to fix our type, parse get type now. So instead of doing this won't be included here at all, which kind of makes sense that the working result will stay with the working result. Okie doke. Eternal Wild Fox says lol. I am the memory wizard. I cast spell, I fix mem. Yeah, actually all you have to do is call fix mem. It's that easy. What does this do? That parses an integer. Binary infix operator. Stack return value. I don't think we need a stack return value. We just need, when we parse these two, no, when we parse a type. Where do we parse a type? I guess we would say invalid type, right? So here we parse a type from the type symbol. And so we're going to have to do like lexing as we go and stream the tokens. Okay, okay. So we're going to say while we're just going to say, I don't know. What should we do? While one. So loop over all. This would be dereference operators. Right? No, loop over all pointer declaration symbols. Okay. Loop over all pointer declaration symbols. So maybe let's lex once and then say while current token value symbol, I guess that's not how that works. So while current token beginning at 0 is equal to the symbol. You could also string compare, but it's a single byte, so we'll do this. So while it's equal to at, we're going to do our little thing here. Say working result is a node type of a pointer. I don't think this is right though. This should be type value. What we want. Type value iterator. Eternal Wild Fox says while one. Eternal Wild Fox says forever and while one is the same. Mr. Mugame says cool kids use forever. Oh, it's true. You're right. We're not so cool today. Yes, it's sad times. We would like to set the child of working result not of working result, of our type value, right? So while we get pointer declaration symbols, and we would like to say, okay, we have a type value of a pointer, and we would like to say type value iterator is equal to children, and then we'd like to say children is equal to a new child, so Cyber Patty, Otsego Electric, how's it going? Howdy, good evening, Lens chat. How's it going, everybody? Thanks for tuning in, Cyber Patty, Otsego. Eternal Wild Fox says easy equals eyes. I know what you mean now. You mean that while one is easier to look at, but forever is a little is bumpy. But yeah, I'm glad you've decided to tune in, Cyber and Otsego. What brings you into today's stream? So, while creating our type value, do the thing. Get the type into the iterator, so our last child should be the type of this type symbol. Hey look, I screwed something up. Well, we're in a forever loop. Let's figure it out. Oh, it's obvious. I lex once, and then never lex again. So let's say lex here. Assertion failed, node type max equals 11, code gen expression. Hey, we got all the way to code gen. What'd we get? A reassignment to pointer to the address of the variable access A. Hey, that. Arusius says you only lex once. Arusius, you are correct. You are a genius. Advanced lexer. Add one level of pointer in direction. Loop over pointer declaration symbols. Perfect. We should probably have this be in a little its own function, right? So this should be like I don't know, parse type. What should this be? We'll just say this is parse type, and we'll say type value is our result. So we're going to need our these three. Okay, we're just gonna write a to-do. To-do parse type. With all the arguments. Arusius, I keep reading your chat, and it reminds me of like, you only live once. You only lex once, man. Do it as much as you can, lex. You gotta lex, man. You only lex once. So funny. So we do this little ditty and get a type. Hopefully the proper type. Arusia says that was the joke I intended. Lamau, that's awesome. As you can see, I'm quite slow. It took me a while to get it, but I did get there in the end. So now equals 14. So let's think about this. It equals 14. We need to do a lot of things. So a dereference and a pointer. No, this would be address of. I don't need to deal with pointer types here. Okay. And then we don't handle pointers on purpose. They are types. They are not a thing. With that in mind, we can now say, ooh, this is starting to work. Dereference is put in the wrong place, however. So how does a variable reassignment parse its left-hand side? Right? So reassignment gets the symbol added to the left-hand side. But that's not necessarily what we would like. We would like the left-hand side of a reassignment to just kind of be our working result so far. Otsego Electric said, a couple of days ago, I tried to dive into how dynamic memory allocation works on more low level and tried to implement my own memory allocator. That was funny, according to this guide. Okay, I clicked on it. So, emalloc with this function signature makes sense. Stack grows down, heap grows up. Makes a bunch of sense. If we want to implement a really simple malloc, we can do something like... See, this is on Linux only. I'm not too great at Linux. Like, what is sbreak? I know that gives you memory, but I don't remember how. How does free work? Free's prototype is this. Free is pretty simple. So for each block, it's not the best. It's a linked list, but it's fine. Nothing wrong with the linked list. Eternal Wild Fox says, should I write the new project also in C? Always write it in C. Mr. Mukame says, if the website isn't using CSS, it's some five-head shit. Lamau. Otsego Electric says, but I guess using linked list is very slow. Otsego says, yes, I think so too. Linked list isn't slow for a memory allocator. At all. Because that's how memory allocation works, is by iterating blocks. Everything here makes sense. The confusing part to me is this pointer arithmetic on the block. It seems like you should use next and not block plus 1, but it's fine. Oh, it's because that's where you store. So you implicitly store data. Weird. Weird. In addition to setting free, it's valid to call free with a null pointer. So we need to check for null. Duh. Yeah. Okay. Really interesting part was exercises at the bottom. Malloc is supposed to return a pointer which is suitably aligned for any built-in type. Does our malloc do that? If so, why? If not, fix the alignment. Note that any built-in type is basically up to 8 bytes for C because blah 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 aren't built-in types. Mr. Mugame says, who needs a heap anyways? OSs are bloat. I mean, this isn't a bad heap at all. It's a lot like the one we have in Lenser OS, if you go look at that. So, I'd say this is a fine implementation. We you definitely don't need this magic, and you don't need an entire integer to say whether a block is free or not, right? So you can store this free more efficiently in the size of the block if you would like, or you can store it as a bit, the highest bit in size t, or you can just have a char to kind of be more efficient. You don't really need that. I don't think you need meta size as a macro. You can just write size of block meta. It's not too complicated. But then basically the idea is that you have a base and you just keep adding blocks onto the base and keep track of their size. So then to get to the next block, instead of saying block next, you just say block plus size of header, and then you're at the next one. But yeah, this is definitely doable. It's a user space memory allocator, so it uses sberk instead of like lower level stuff, but it's fine. Absolutely fine. It's very complicated because it's a memory allocator, right? But it's definitely doable. But Otsego Electric, don't feel bad if you get confused. It took me like 2 weeks to just get memory allocation working at all. And then I spent like a month figuring out how like the bootstrapping of memory works for the OS. So don't worry. Heap and memory management, that's all very complicated. So if you're able to understand it at all, you're making progress. You know what I mean? So we don't just want the symbol on the left-hand side. And we don't just want to set working result to variable reassignment. Because working result, we want to possibly have the left-hand side. Because this is not a null denotation. It's a left denotation. Hence this. Whereas these are null denotations. So we would like to capture a null denotation. Ideally, all of the null denotations could be first, but that doesn't work out like that due to having to look up variables in environment. So we get a type. We can do all that. That's working. But our reassignment, we cannot just have the reassign. Hey, look, we create a reassign here. Again, using the wrong using the wrong tactic. So this is fine. This is fine. We'll just have to figure it out, right? So when we are parsing a variable declaration, we will say that we have already parsed the left-hand side into a node. That would be the ideal, but that would mean we have to check for a variable access at the top. And I don't know if we can do that. Can we do that? I mean, checking for a variable access is basically saying it's nothing else, right? Because we have to look ahead for everything ahead of a variable access to see, is it a function call? Is it a binary operator? Is it blah, blah, blah? So we have small issues. We can get a dereference or address of operator. So address of is working fine. It's just fine. But the problem would become using address of in an assignment on the left-hand side. That's also not allowed. And then you see to do, we don't know how to code gen these at all. Okay, with our bloated operating system, we now need to figure this out. So when we parse a dereference, this is so interesting. So it's almost like when we get this unknown symbol, right? We have this unknown symbol that we don't know what it is. And then we do a bunch of testing on it to see like, okay, what is it? Try and return a node based on this symbol. So the idea would be that our working result is now set to a child. So whether it's a dereference or an address of, we would just like to get a variable access afterwards, right? And in the case that working result is a variable access, we should look ahead for a variable reassignment. What do we do now? Why do I have that backwards right now? Because right now we don't do that. Our control flow is again, wrong spot. We get an unknown symbol, check ahead if it's a variable reassignment, and then check if it's a variable access. See, this isn't making sense. Right? So our unknown symbol, reassignment of existing variable, look for equal. See, shouldn't we expect this, and this in a variable access instead of the other way around? I don't know. So let's think about how this works. We have else here, and this else is to finding. Okay, so this else is to finding a colon after an unknown symbol. So this would be like symbol colon. So unknown symbol colon, that could be a variable declaration. But before, we don't know yet that this symbol is unknown. We may actually have something like var, right? And then this. And when we do var, that's why we have to check for reassign here. But if we check for var right here, check for var here, right? Arusius says, any reason you're using at for dereference? We talked about it at the beginning of the stream a little bit. We can use at for dereference basically because you can read it. At pointer, write 4, right? So you're not saying pointer is equal to 4 or pointer is assigned to 4. You're saying at pointer is assigned to 4. So it kind of reads better, in English at least. And then we also want characters that aren't multiply, so I don't want to use multiply. That's multiply. Arusius says, interesting. Yes, but if we use multiply, it's like, this becomes hard to parse, you know what I mean? Arusius says it's opposite to how Pascal does it, Lamau. Yeah, Pascal, it just does everything differently, though. In Pascal, at means address of, which also makes sense, but I feel like the C syntax of ampersand being address of will be okay, if that makes sense. Arusius says, yeah, that's fair. But we also may want to support different syntaxes in the future. Check for variable access here. Right? So how do we know if it's a variable access? We know if it's a variable access if we get a variable binding. So we get from the variables environment, from the current context, the variables, we get the symbol into variable binding. This doesn't get from parent environments. So we have to write a little parse get, right? And we're going to write parse get variable. And we're going to take in a context. We're going to search. I guess we could do parse get in context, and then we could take in whichever environment, but it's fine. This is fine. So write into result. This all seems just fine. So then we need to say while parent effectively. Status is equal to environment get. I don't think we need to get by symbol. I think we can do like that. I don't know why we did it the other way. Do you? So we would like to get in the context variables environment the ID symbol into result if status environment get returns 1 on success, 1 for success. So if status, return okay. Context equals context parent. And if we get here, we have to say result type equals node type none. And say variable not found. Something like that. And then we'll prep an error and we'll do the same thing. Hey, haha. Hey. So now we have parse get variable, where we can look up a variable in any parent context. So the idea would be to check for a variable access here. So we should say node pointer var binding equals node allocate free var binding. And in between here, we're going to say parse get variable using symbol in our current context and parse into var binding. If not, nunp var binding. So if we have a binding of the variable, then this means it is a valid variable and we should create variable access. Awesome. Create variable access node. So let's go find our variable access and see if we can't copy that on up. What is this? So we get, okay, function call, variable access. So here we do check the parents. Then this is where we say unknown symbol. And then here's where we create it. There it is. It's that easy. Alrighty. So then, look ahead for variable reassignment. What else might there be in a variable access? Right? I don't think anything. So if we do get this variable access, how do we return it? Right? Are we just done? Do we have to jump back up to handle stack operator? Where are we at? You know what I mean? Let's think about where we're at in parsing. So if this fails, and it is nunp, then that means symbol is not a valid variable name, and so we should check for function call or new variable declaration, right? Did that one wrong. Wow. Alrighty. If anybody has any questions, let me know. We are working on the parser right now, trying to rearrange it a little to make more sense and do look ahead instead of look back. So if symbol is a valid variable name, we're going to do this. And then we're going to have an else, right? We want to free this either way, so we're just going to leave that there. So else, we're here. And in this case, we can check for function call or a new variable declaration. So a function call, yeah, that's fine, is going to be the same, and then a variable declaration is going to be like this. Oh boy. Okie dokie, okie dokie. So we now parse a working result and then fall through. So we want to move all this stuff into the otherwise, because a variable declaration we only want to happen here. Not here, but only want to happen in here. Whereas a variable reassignment we only want to happen in here. So getting these two nodes in a row means that we should get a reassignment. We already know it's a valid variable, so we don't have to worry about returning that error. We can just do this. So we already set working result to the variable access. So now that we get this, we should say node pointer reassign equals node allocate, right? And then we're going to say reassign type equals node type variable reassignment. We're going to add child of working result to the reassign. We're going to make a reassign expression, add that as a child to the reassign, and then parse into the reassign expression. Variable not found A and variable not found putter. Variable not found. It's almost like the error didn't get bubbled up because it didn't. Well, I guess we may not want to do that. Variable is not found in environment. Which one and why? A. So yeah, we don't want to do that. But we do want to do that. So effectively, if there shouldn't be an error, check that there hasn't been one. But there may not be an error because it may not be a variable access. It may be something else. We're getting there. We're getting there. So we have a variable access pointer and an address of variable access A. So this variable access pointer is being created here. So in front of pointer, we should get and A. See about this reassign node. So we kind of need to change our working result to this reassign node. Okay, so here's the issue. We have our working result and it contains our left-hand side. So we're going to say node pointer left-hand side. Do we still have node copy, by the way? Is that still a thing? Right, so we can do this. Then we should set the working result to a variable reassignment. We would like to add the left-hand side as a child. We would like to add the right-hand side as a child and then parse into the right-hand side of the reassignment. See, but we still get this dereference of a variable reassignment. Because our working result is equal to a dereference, but then we say working result type equals variable reassignment. But our working result, okay, here's the thing. That is now working, and that's great and all. But the dereference of a variable reassignment, that's not correct. We need a variable reassignment with a dereference of pointer, right? So this variable reassignment, hopefully, are we getting here also? I should make sure I'm actually here. Always do this. Okay, we are here, and we get variable not found twice, A and putter. So variable not found twice, A and putter. Because we look them up, then go on to create these. So let's make sure that we don't check for equals. We don't need to. We should still get reassignments. Proper, okay. I'm probably breaking everything, by the way. This is terrible. Alrighty. Let me drink some water and think about this section of code. You'll notice I never actually increment current token beginning, so that would kind of be an issue. I'm just gonna have to do like plus plus, right? That would be one issue. Please, thank you. So we don't always want to print something out because we're gonna not find one a lot. Type not found integer. Okay. One of these. Here it is. So the idea would be to do that here. Actually, no. Okay, that's why I'm silly. We advanced the lexer. We don't need to increment this. I'm a silly boy. This is not string iteration. This is token iteration. Okay, so this variable access of pointer we parse correctly, which is so interesting. This is so interesting. So our dereference is in our working result, and then working result gets set to the child. So working result is the child of dereference by default. So this should contain a variable access. Yes. Then this entire thing, it's almost like we need a stack result, right? It's almost like we do. So the problem is that we need to have access to the parent of working result. I really don't want to add a parent pointer. Should we just add a parent pointer? That's not a bad idea, because then we could just say working result is equal to working result parent. Because that's actually what we need to copy. We need to copy like the result so far. Maybe just result. Let's try this. That did work. But I don't know if it would in any other case, right? So let's think about how this could go wrong. Like what if we're parsing a function and inside the function we have a variable reassignment? This would mean that we copy the whole function to the left-hand side, which is not what we want. Right? Ah. So let's just test that. Let's test that in a function, which returns an integer or whatever. Sure. Why not, right? Okay, it does work. Confusingly enough, it does work. But it still breaks. So if I did that, then it's going to break. So we have a function. Oh boy. I sure did break something. See what I was talking about? So the function result got placed as a child, a copy of it got placed as a child on the left-hand side, when all we actually wanted was variable access putter. So it's like, oh man. Oh, this is annoying. So it's like when we parse a null denotation. Because however many we parse of these, right? Each time we parse one of these, we need to say like, hey, by the way, don't update the result that you use in that one way. So it's almost like I need to test for the colon here. And then say, okay, what was our Because if we come around and we go for the colon here, see, that's the same thing as we do down here. Okay, so that wouldn't work. Bad idea number one, out the window. You gotta have 1,000 ideas, that way 999 of them can fail. So if we get a variable, then we create a variable access node, right? And then look for a variable reassignment. A variable declaration means that it's not an existing variable, and it'll be in here, or whatever. If we just get a variable access, and there's nothing ahead of it, then I think we're done. To/fix me. Is this correct? Well, the thing is, when we get a variable access, we should look ahead for a binary infix operator, right? Didn't we do that before? We do it here, which is after this. So we should just, effectively, we just need to get out of where we are. Because we are in this else. We need to say, if that, then fall through. So variable access. So we need to say, if not this, then just fall through. So this is not correct. We'd like to fall through and say, otherwise, don't do anything else. Do other things. I should have kept a better track. I think all of that would constitute in here. That doesn't seem good, does it? What's going on? Okay, I feel like I screwed something up, so I'm just gonna go back. We're doing all the undo in the world. That's not correct, we figured out. Okay, so the idea, let's go a little smaller on this. We have, what do we have? So we expect a variable declaration and make sure it's not a redefinition. And that is here. Else, we check if it's a function call. Else, we don't know what the hell to do. So this is that else. This, what does this refer to? That else. That's too far, right? So we want this else and up, I believe. Just to here. And then place that in there. See, but this just jumps to the same, not correctly indented. There we go. See, what is this stupid shit? Why can't it indent? Hello? Like, what are you a part of? Jeez. The indenting was rough, and ingres is not a thing. It says stradoop. Look at this compiler error. Hey look, it's not just me with the compiler errors. Look at this broken language server. It's telling me stradoop is here. And here. Oh Christ. We're gonna reconnect. Okay, we're back. We're back and in action. So we don't actually ever need a variable access node, is the cool part. And I don't think we need this variable thing either. So we should just say unknown symbol. Error, internal compiler error, sad face. Oh, great. I wonder why. Probably because we tried to reassign a function. It's fine. Where is that internal compiler error? It's in parser.c. And it's when it's an invalid handled stack operator. Okay, so we're probably falling through where we should not be. Somewhere, at least. So the idea would be that, see, this checks for an initialization. Check for initialization. Hey, look, font lock is broken. A lot of things are breaking today. So check for initialization after declaration. My comments, can I like, don't need ew. What do I need to reload? Font lock? There we go. Please no crash. Okay, there we go. That should fix it. Emacs, Emacs, Emacs. Okay, so check for initialization after blah. This seems fine. This is a problem. Yeah, I don't know why it's not working now. Font lock, why? In any case, it doesn't matter. They're just comments. This is a problem. We should use working result or something. Left-hand side, copy. So the issue is that basically we currently do result. So let's do working result, and just so we get things that are less broken. And let's think about it. So we don't really need a stack for dereference. We only need to handle a chain of dereferences. Well, we need to handle a chain of dereferences as a single expression, right? Interesting. So we do that. It's just that our chain of references is written into working result, which may be anywhere. So can we do something like every time we get an address of or a dereference, we're here, right? And every time we're here, we know that we're at the start of an expression that may have children. So it's almost like we could create a stack every time we get here. But in any case, what if we did create a stack for dereference and address of? What would it look like? How would we handle that stack operator? I mean, we would just get rid of it, is how we would handle the stack operator. We just pop the stack because we don't actually have to do anything. We just want to keep track of the stack result, right? So then we would create a dereference stack, continue, dereference stack, continue, dereference stack, continue. But it's almost like we need a singular stack because we just need to keep updating our last result value. You know what I mean? This is so confusing. I don't know why I am so stupid today. So, yes, this is what I wrote last night. It seems fine, but in practice, in practice. So the idea would be that more pointers. We parse some at, right? And we go okay, that is a dereference with a child. Parse into here now. But then when we look ahead, upon look ahead for variable reassignment, we need that entire left-hand side. We need that entire result, right? Starting at chain of dereferences. To the left-hand side. On the left-hand side. So upon look ahead for variable reassignment, we need the entire dereference blah blah blah, starting at a chain of dereferences. So how do we start at a chain of dereferences, right? We could either do all of the dereference parsing in variable access. Do we ever want to dereference something that isn't a variable? I do not believe so. We're not going to do like raw pointers where we can just convert integer to pointer. I think that's kind of dumb. We may have pointer arithmetic eventually, but a pointer, a dereference will always be on a pointer variable. We're not going to have like, I don't want dereference 4. I don't want this to work. You know what I mean? I only want dereference bar or like a variable. So what if we just move that into variable access and said while see, here's the thing. Here's the thing. We look for a variable here. Check for variable access here. So to know it's a variable access, we have to have the symbol, which means that we can't have these here. So effectively, we'd have to do something like, if we get one of these, we'll say if we get a dereference operator, then aren't we going to have like a must be var access or something? Right? Because I would like to parse another expression and then type check it eventually. See, that's the thing. In type checking, we should do all that. So why do we need... I feel so dumb. I feel so dumb. I want to die. Okay, so we're gonna just put this back at the top because I'm feeling dumb and I don't want to do split things up. Okay. We have at. If we get a dereference, we continue and set the result to the child. But from the child, also let's do this correctly. Like that. So whatever we're parsing into, we say, okay, go ahead and add the child. What we could do is have add child set a parent pointer in the child to the parent. We could do that, but the problem lies in the fact that, well, I guess that would be fine. We can have a parent pointer. I don't want one, but we can have one. So we'll say new child parent equals parent. Yes, I know. This is 24 bytes. size of 4 bytes. Well, it's fine. So on a 64-bit system, this, maybe ClangD is 32-bit. Maybe that's why it crashes all the time. Okay, so what do we get? We get a function that has the same dereference variable reassignment problem. So now, when we get a reassignment somewhere, and we copy working result to left-hand side, we'd actually like to do something like this. So left-hand side pointer. Which is just going to equal working result, while working result parent and working result parent dot type is equal to node type dereference. Right? Then please, we're just gonna do, yeah, we'll do this. Please set the left-hand side pointer to working result parent. Don't want to update working result, so I'm gonna have to use the left-hand side pointer here. And then it's going to equal left-hand side pointer parent. So effectively, while the parent is dereference, go all the way up the parent tree. Oh, I hate this. I hate this so much. Okay, then we copy from the left-hand side pointer into left-hand side, and then we use all that. It nearly works. So we still have, okay, so that now works like that, but we still have the issue that dereference gets placed before a variable reassignment. So it's almost like we have to detect a variable reassignment and then parse the left-hand side and then parse the right-hand side. I have figured it out. I figured out where the stack goes. Boys, chat, we're back at it. We're back at it. Okay, I have an idea. So the problem is that I was thinking the stack has to do with the dereference operator, and I was like, there's no way we should handle that stack. But the stack is actually, the parsing stack should be created under a variable reassignment. All right? But the problem is that the left-hand side was just parsed. That was what we parsed last, right? So we kind of can't go backwards. So how can we create a stack that parses the left-hand side properly? We'd have to kind of have so what if we just had last? Okay, this is very dumb, and this is not going to work. Node pointer reassign left equals working result. I don't know. So yeah, by default, just use result, right? That's fine. So then, every time we say, so this, I'm just going to call this parent expression. I don't even know what to call it. So parent expression, it's going to equal result at first. But if working result gets updated, parent expression should not. So it equals result here. So in which case should parent expression be equal to result? or working result. So I think it should honestly be here. Because if we parse an integer, that's definitely the parent expression, right? It may not be. That's the problem. So if we parse at and then continue, we're going to get back here. So we don't necessarily want that. But we don't just want to use result. Okay, boys, I'm confused again. I almost had it. But the problem is that a variable reassignment, we can't parse the left-hand side after encountering it. So we have to somehow parse this left-hand side and then look ahead for variable reassignment. How do we do that? So we can parse the left-hand side into like result or whatever. But if we're in a function, then left result is actually equal to the function. We just want the local left-hand side. How do we do that, man? So each expression we parse almost needs to have this set. But a single expression may have multiple expressions within itself. So without recursion, it's a little difficult because recursion lets you keep things on that stack, on the hardware stack. But we can't keep things on the hardware stack. No, no, no. We have to keep them on the heap allocated stack that we create. Which means when we parse a variable access and we look ahead for a reassignment, the thing we just parsed, yes, was a variable access. So how do we denote that, like, the actual last expression we parsed? Well, if we had our parent expression set to result, and then we hit dereference, and then we hit a variable name, we could just use result. When does result become invalid? Parent expression. So result can no longer be used. Result can no longer be used if we are parsing nested expressions using a parsing stack. So can I literally just use what if I just use the existing stack result? Am I an idiot? Okay, I may be dumb. But I'll make up for it with sheer willpower. I'll get things done. Okay, so parse function body. Here it is. So in a reassignment, we could say that the left-hand side pointer, instead of doing this thing. Oh, and here's the thing. Okay, so if stack and stack result, left-hand side pointer is going to equal stack result. Otherwise, what's it going to be equal? Otherwise, the left-hand side pointer will just be result, aka parent expression. Right? So left-hand side pointer equals result. If there's a stack, then we use the local result. Like this. Then we copy. So let's just try this, because the left-hand side result should be dereference. I really wish my fontification was working. Nearly. Still incorrect. Why is that? So our stack result is dereference, is it not? So that's going to be our left-hand side, but that's also going to be where we write to. So we'll copy the left-hand side pointer. So this is going to be, let's see, we copy the left-hand side pointer, into the left-hand side, so then we can overwrite the left-hand side pointer. This is not a good name, I'm realizing. Nearly. Nearly. So dereference already has a child that we parsed a variable access into. So we need to reset left-hand side pointer after doing this copy. So we need to say like left-hand side pointer. We need to like just mem set it to 0, right? Fuck it. Hey, look, we use size of in the proper way. And it works! Pog! Chat. That was way too difficult, and I'm way too dumb. Oh my god. Eternal Wildfox says coffee time. Hell yeah! That's awesome. Oh, and I missed 2 follows. I feel so bad. Olring Drazer, 9 minutes ago, thank you for the follow. And Bugina, followed 6 minutes ago. Thank you everybody so much for watching. We got those lurkers in the background. We got them follows. This is perfect. Okay, I think we're parsing things now. That was... Eternal Wild Fox says, so be right back. Yes, yes, we will see you when you get back, Eternal Wild Fox. Thank you for tuning in, and be sure to get some epic coffee. Coffee's always good. I don't drink it, but a lot of people do. So we have a function called foo, and it contains... It's the only thing in the program. That makes sense. There's nothing else. It contains no parameters. It contains a return value of integer. Mr. Mugume says, the Zodink transformation completed. Oh no! I am become Zodink. Yeah, I will be strong. No? That's gonna be my my series arc. 100 episodes, Morty. Morty, 100 episodes. I'm gonna become Soding. So good. So we have a variable declaration, A, with a reassignment to 0. So that's this. We have a declaration of pointer, and then a reassignment of pointer to the address of A. Then we have a reassignment of the dereferenced pointer, yes, to the integer 4. Yes. Variable access A. Yes. So this function should return 4, ideally. And if we look at the code that's being generated, it's going to be confusing. So we can move 0 into A. We declare a local variable here and here. So this is A, our local variable declaration. We should probably keep our... like put the name of what variable it is. Let's do that. Let's go do that in CodeGen. And this is going to be expression children symbol. Symbol value. I did that backwards. And now if we take a look, that's much better. Variable declaration of A. We should probably just output like the token spans eventually. We'll get there. Then we have a variable reassignment. Again, same thing there. See, this isn't going to work on dereferences or anything. Ah, that's annoying. Okay, we're not going to... This will work for declarations, but this won't work here. Good to know. Reassignment, not done yet. In any case, we reassign... We're getting null. This isn't good. Chat. So, why do we get null? A reassignment from 4, and we get null. Oof. Eternal Wild Fox says back. That was so fast. Oh my god. So we get foo, and you can see that we get a variable declaration A on the stack. We reassign A to, yes, that makes sense. We reassign A to 0 here. And then we say declare the pointer variable and move racks into null. See, why does that happen? So what's the second one? The second one says symbol to address. And the symbol to address is on expression children. So in this tree, it looks like when we are getting a reassignment, we are just using the child as the symbol, right? Which works until there's a dereference on the left-hand side. So to do, right, would be to handle dereference nodes on their own, right? So we codegen the codegen the reassignment node, but what if we codegenned to get this node as well? Right? Okay, that's something to think about. So why is result a thing? I just do this. We can just do that. Okay, so the problem comes, dereference is not a symbol. So trying to get the symbol to address will not work. The idea would be that we have to first figure out, we basically have to codegen the left-hand side expression, no? And then if it's a dereference, okay, we'll get there. We'll get there. In any case, we should probably type check things. Let's just work on the type checker because it's pretty awful right now, right? Perfect. So let's do no type function. So to type check a function, we're going to have to, first of all, enter the function context, right? So I'm going to need some like parsing context. I guess I'm already within a context in type check expression, right? So then I should just say in a function, this will advance the nested context, right? So this should say context equals context children or next child, probably children, but not always children. So how do I do this? So let's look at how contexts are created. So we say parse context create and pass in a context. And parse context create basically just sets the parent, the past context, as the context's parent of a new context. The parent gets context as a child. And then we basically just initialize the context. So parent getting context as a child. What does this mean? What does this mean? So we have this parsing context and we add a child to it. So we have parent children, but also next child. So we have to keep track of which context that we are within in the children, right? We're going to need like parent context and working context. Is this correct? Yeah, so what we're gonna do is have like something like this. Probably not here. Context to enter. So this is the next context we will enter, right? And parsing context. Pointer, context to enter. Already tidy. Not doing too bad. Pretty good, pretty good. I'm probably gonna have to take a small break in an hour at around 11:30, just so everybody knows. I'll probably be gone 5 to 10 minutes, so I may stop the stream and restart it, but or I may not. I may just leave it going with some royalty-free music. In any case, we now have a context to enter. So we would like to say this context to enter. We should say context. Well, let's see, what do we want to do? How do we deal with this? So for a function, we need to ensure return type is valid type. I think we already do that during parsing. So we need to type check body of function in proper context. So what if we just do this like this? So we want to say if error.type, return error, type check the expression of the context to enter. So this would be context next child or context children. Or see, this would be context to enter. I think this makes sense. And I'll dereference that. Perfect. Then context to enter would be context to enter next child, right? No, it would be children. So we're going to need a parsing context pointer to enter. This is going to equal context children, right? So we're going to say this is going to be to enter. Like that. Okay, so we have a parsing context pointer, and we are saying in the context to enter, we have children. So because we're going to enter this context. So we're getting the to enter of the to enter, effectively, is all this is. So then all we have to say is node pointer expression. So the expression would be expression, children, next child, children. Child expression. We'll do body expression, right? Why not? Okay, so now we have a body expression that starts here. And say while body expression. And we can type check it. So we type check this function's expression in a recursive way. We'll fix this eventually, but we would like to type check the body expression. And then say body expression equals the next expression in the body. And effectively, if you can imagine, if we had a nested function, then we would have to enter equals its child, and then go on like that. And then, when we're done with the function, we can say that context to enter is equal to context to enter next child. So we recurse into children in here, but we recurse this context to the next child. So if we had two functions in a row, we should get two parsing contexts in a row. Lots of issues. Okay, what are they? Passing argument to from incompatible pointer type. So everywhere else where I called type check expression from. So I just pass those by. Expression return type. So expression return type, I may need to type check from. So we're going to need all the arguments that we get there as well. It's not a stack, it's a context. Context to enter. Yeah, I don't like that. Alrighty. And now, yep, it's going to be angry. I wish the it wasn't so broken on the highlighting. I don't know why it's not going so well. Conflicting types for expression return type. What is, oh, node pointer expression. That got messed up somehow. Also, that's the wrong one. Gotta love it. We'll get there eventually. Wonderful. What's the issue? A label can only be part of a statement, and a declaration is not a statement. Wonderful. So we're gonna need like parsing context. We enter child to enter, right? And then we'll just say, that sounds, that's a little sus. We're just gonna call it to enter. Eternal Wildfuck says, going to get a second mug of coffee, but yeah. Get that. Passing argument to from incompatible pointer type. So this is where we need, why is it opening multiple fucking files? God, that's annoying. Just bring me to it, thank you. So expression return type requires a context to enter. That's valid, because a binary operator does not create a context. Okay. Nearly. That one should be fine. So now we're going to have parsing context to enter equals context children. So this should be updated as we go. Well, we didn't get a type error. So now let's type check expression on, okay, so we call type check expression on each body expression. So what we'd like to do, so case node type function, case node type variable. Let's see, so a variable reassignment. So we have to do a few things here. To do, hey, our highlighting's working again. Hooray. So we have to get type of left-hand side variable. Be reference adjusted, right? So we need to basically call expression return type on our left-hand side. Let's try that. So I'm such an idiot. Node pointer type equals expression return type. Context to enter. And the expression is the current expression left-hand side. And this is where we're supposed to write into because it returns an error. So we're going to say we can't do this here, but we do have a temp node if I remember correctly. Yep, we can use temp node. So when we do this variable reassignment, please write into temp node and keep track of the error. So expression return type into temp node. So expression return type has to change to be a node pointer type. And this is going to be a whole thing. Type equals result. Result. We do free results. That's going to be an issue. Right? So we're going to say result is now type. So we're going to say type is equal to -1. By default, the type is just equal to the expression type. But if it's a binary operator, we would like to say get into, so we're still going to have result, just not going to be used in the same way, right? Because it's going to be type. It's true. Into result. Okay, so basically, a binary operator, we handle the return value, because a binary operator, it's declared what its return value is when we declare one. CyberPatty says, which C default style are you using? I think GNU. CyberPatty says, I'm going to write something in Emacs. I didn't even know C default style. Is that a thing? Apparently these. There you go. So in like C major mode, I use the GNU as what it would be. Cool. But yeah, I use GNU. I use strip and others for like C++. CyberPatty says, yeah. Okay, so now that should set type, which we are returning as a result. So if environment get into temp node, get the type. Okay. So this should say temp node contains a function node. Variable access. Environment get temp node into result. Something like that. Because we get the variable here. So we can say variable is going to be equal to expression value symbol. The type is going to be temp node value symbol because we didn't get the type in type. Bunch of errors. Expression return type, conflicting types. I don't think so. node. It runs, and we don't get any errors, so that's either really good or really bad. Passing argument from incompatible pointer type. So now, type is not just an integer, it's an entire node structure. Right? An entire node structure. So what we have is this type structure, and we're gonna have to do some comparisons. It's gonna be annoying. Okay, so for a binary operator, we need to get the return type of the left-hand side into type, right? And then, if error, return error, but if we get it, then we can get expected return type of left-hand side in temp node type. Yes, so this is what should the left-hand side return, and what does the left-hand side return for the binary operator. And when type does not equal expected type, then we should error. But this isn't right, because we would actually like some way to say compare two types. So we're going to say types are equal, return 1, otherwise 0. Rohan says, it won't be as bad as my comparisons. I have to compare data and fill it in by hand. Lamau. That's rough. Type compare. We need to go write this. And we're going to say, basically, if A type does not equal B type, return 0. And then we're going to say, while children, right? So we're going to have node pointer A child and B child. While children, I guess I'm going to need something. While child iterator equals children. Child iterator equals child iterator next child. And then we're going to type compare. So we're going to have to say if type compare child iterator. I'm going to need two child iterators. While child iterator A and child iterator B, if type compare, so then we're going to say if child it A equals child it B, so they should both be null, and we can return 1, otherwise return 0. Okay, so the idea if not type compare, okay, if that equals 0, we're going to return 0. If it's 1, keep going. So if A type does not equal B type, return 0. If all the children match, then return 1. CyberPatty says, I set the C basic offset to 2 in .emacs, and I have indent tabs mode nil. Still, Emacs tries to use 8 spaces inside function definition. That's terrible. C, what does it prefer or something? So what's C set style? Switch, if you call C set style, if you set it to GNU, right? And then C set offset. See, C set offset is something different. I don't think I've ever touched that. what did I do? I did the prefer coding system? No, I can't even remember. I don't even remember how I set it up. But there used to be, in my old mode line, I was able to just click on the mode and it would pop up like change style, and I would use that. But yeah, I'm not sure why that is. It shouldn't happen that way. So is this C indentation style set? C set style worked. Hey, okay, so I did remember. C set style GNU. Pog. Gnarly Quack says easy solution is to not use Emacs, Kappa. You're right, Gnarly, you're right. Cyber Patty says gop. Hey, that pog. Rohan says, and I don't even know what you're talking about. Wow. We're basically, he's in Emacs, this text editor, and we're trying to get it so that when you indent things, because you can press Control-I to indent your region or the line you're currently on. So like if it's here, and then I press Control-I, see how it goes 2 spaces past the parent indentation, and this goes 2 spaces past its parent indentation? That's because of the C set style GNU. Whereas C set style for like Surstrip or Java makes 4 spaces or 8 spaces. It's terrible. Rohan says, I understand now. Thanks. Of course, Rohan. Anytime. I am here to help. So type compare, we should basically be able to compare the left-hand side and the right-hand side. So if A is equal to B, and that's it. So like, let's say integer, integer, right? So these would both be null because children are null. So this wouldn't run. These would both be null, so they're equal, and we'd return 1. Okay, so I think this will work. I think this will work. Did I screw this up somewhere? I don't think so. All right, so now, when we get this type, we would like to say not type does not equal, right? We would like to say if type compare of, let's see, the temp node, the expected type, and the actual return type is equal to 0, then say, hey, problems. Okay, this seems like it makes sense, so we can do the same thing down here. Using type and temp node.type, type compare. Well, we don't get type errors yet, so we're doing okay. So we have to compare result and type here. Hey, look, it's working. Rohan says, just wait for them. They are hiding, Kappa. Lamau. Okay. This is starting to make sense. I would like to remind everybody I've been streaming over 2 hours today. Be sure to hit that follow button on Twitch. Check out the YouTube for all previous broadcasts and videos on demand. And as well, be sure to hit that donate button if you are feeling entertained and extra generous today. If you can't hit the donate button, don't worry about it. All I care about is that you are here, positive, and having fun. Alrighty, so we type check function calls now by getting the function. We then iterate over our parameters. And for each parameter, we say argument type matches or does not match. Okay. using type compare of result and type. That seems valid. So now, let's try and introduce a type error. Still works. It still works. So are we still not doing variable reassignment? Yeah, we didn't do that yet. That's why. So we can get the return type of the left-hand side variable dereference adjusted, right? So we would like to, let's print this node out. So we have, what? This variable reassignment here. We have this one here, and this one here. So the idea is that the left-hand side, so a variable access, we already can get the return type of, right? The return type of a variable access is just the variable's type. And the return type of a dereference is what we have to work on next, right? I think that's what we have to work on next. So upon getting a dereference, we will say, hey, to do validate, is this type check expression or return? So this is return. So the return value of a dereference. So the return value of a dereference would be whatever its child pointer, whatever its child type is minus a pointer, right? So we would say like error equals expression return type on its child, right? Well, we should probably say type check expression on its child. And then we need context to enter. And this is expression. What did I miss? Nothing. Okay. So when we type check the left-hand side, well, the only child of a dereference operator. So we have a dereference operator, for example, here. So we would like to say, get this type, right? We want to get this type. So it's almost like type check expression should return the type of the expression as well. So we're going to say node pointer type. That's going to happen. And then we can just pass it to expression return type. So when we type check expression, we'd like to parse into type, which will set our result all the way up to the top to this one expression's type. Do we want that? That's not necessarily what we want. We want to set all the way up to the top the return type to. So I don't really want to type check this expression and then get its return value. That seems really inefficient, right? Like doing that. So what we should do is expand type check expression to contain type result, right? We'll say result. Why not? We'll call it type. Well, both are used anyway. So the idea would be that type is the result of this expression. Which, how do we do that? That doesn't really work because we never get the return type of this expression. So when type checking, we don't need the return type. Okay, we're going to try this. We're going to try this. Yes, I know, issue. Expression return type. Expression return type should definitely have type. What's it talking about? Type undeclared. Oh, did I get rid of the type? Yeah. Okay, we're getting there. So the, whoops, dereference. We can type check a dereference. We can then return the error if we get an error. Okay, error, and then we would like to get return type of the child expression into type. That's going to be context to enter. Alrighty. Awesome, awesome. I got something to respond to on my phone. 1 second here. Okay. We're ready. Sorry, I hate silence, but I like to just get it over with as fast as possible. Rohan says, looks good to me, man. That's right, it looks great, man. Okay, so we get the expression return type of the child, and we would just like to say, we've already type checked the child. Don't necessarily know what that means, but if it's a dereference, that means we should ensure its child is another dereference or a pointer. In either case, our return type, right? Type would equal type children. And I think I should just like mem copy into type from type children, size of node. So we need string. Rohan says, soon TM, the comparisons have an end, PogChamp. Hey! No more data entry. So reassignment. So we get the return type of the left-hand side, which means that the return type of a dereference, which is what we're working on now. So the return type of a dereference is the type of its child minus 1 level of pointer and direction. Pretty pog. So type checking a dereference, ensure child is either a variable access or another dereference. Ensure child return type is at least 1 level of pointer and direction, right? I think that makes sense, because dereference needs to work on pointers only. So ensure the child return type is at least 1 level of pointer and direction. Oh, this is so confusing. I'm going to be going back and forth a lot. Okay, so type checking an expression. Let's give ourselves an expression and figure out what we need to do. Pointer A, which I guess would be at A. So this would be a dereference with a child of a var access of A. So in this case, we could say, do we want to just check the one node? Maybe let's try that. So a dereference of a var access. So var access return type is just the variable's type, right? So this return type should be at least one pointer. But we could also just say this needs to be a var access node or a dereference or a memory address. No? So let's just get the return type. Let's do it that way. Context to enter. Rohan says, well, I was talking about your comparisons. Mine will take a while and I'll continue tomorrow. Lamal. Lamal. You're probably right. Rohan says, ERP data maintenance for a web shop with dynamic texts, etc. Kinda annoying to deal with. That sounds ultra annoying to deal with. Oh my god. Christ. So the return type, and we just need to say if type does not equal node type pointer, then the return type of its child was not a pointer, and you can't dereference something that isn't a pointer. So we're going to error prep. Error, I don't even know what this is. Error syntax. We're just gonna go error type and say dereference may only operate on pointers. Turn error. So now let's try and dereference something that isn't a pointer. We're gonna do like @2. It worked. Dereference may only operate on pointers. So now if I did something like, for example, like @a is assigned to 4, everything is fine. Why is everything fine? So we have a variable reassignment of a dereferenced a into 4. So maybe we're not type checking the reassignment. That's why. So we get the return type of the left-hand side, which is going to return whatever the return type of the dereference is. Right? So expression return type, we're going to say, okay, dereference. So binary operator, what do we do? I'm just curious. We say type check expression this binary operator. So getting the return type of a binary operator should type check itself. So maybe a dereference should type check itself as well as its child. Is this valid? Dereference may only operate on pointers. I think that's what was going on. So we need to type check this expression. Again, if type check expression returned a value, everything would be fine, a type value. So the problem is that dereference is operating on something that it should be able to. But now we have a problem, mismatched types. Dereference may only operate on pointers. So dereference may. So let's print our type node. Our type node is integer 0. How? See, this is wrong. Symbol pointer is pointing to integer. So it looks like maybe in the parser, when we do pointer, where do we lex the pointer? So when lexing types. So I think I did type value is what it was. Yeah, so type value. And then get the type into type value iterator. But then when we create the binding, so shouldn't we environment set somewhere to set the type? So we get the type. Type value is then freed, which is a little concerning. So we don't do an environment set. So a variable access, we're looking for a variable declaration. Variable declaration here. Okay, so then we have symbol for environment, which is equal to symbol. Then we have, shouldn't we do an environment set? How are we never doing environment set? It's right here. Okay, Christ. We just did type symbol. So type symbol. Why did we do type symbol? What is type symbol? So type symbol is just the singular symbol that we got. And truthfully, we would like to set this to type value. But I don't know if that's going to work in all cases. Cannot get type within context for variable access return type. Type is null. Variable is pointer. What did it say? Could not get type within context for variable access return type. So a variable access return type. So we're storing. Interesting. Is it correct now, though? It is now correct where pointer is a pointer to an integer. So we're nearing. We're nearing. Arusia says anything related to ERP is always annoying. Yes. Rohan says, well, the data programming parts are fun, but I'm in my first year learning this, so I have to do this stuff first. Oof. You got that grunt work you gotta trudge through, right? So why is type null? Right? So we're not saying type not found. Could not get type. Type within. Where is that from? Where is this message from? We're gonna have to like grep for it. Hello? Okay, grep just did not do anything. Nothing at all. Okay, well, grep, that was quite useless. Oh, there it, it just took forever. It's in the type checker. So this is in a variable access. So what are we trying to look up? Temp node. Rohan says, yeah, gotta know the system, articles, customers, etc. before you can actually start working on stuff related to ERP. Yeah. You definitely have to be in the ecosystem. Temp node. Okay, temp node, temp node. So we get by symbol, expression value symbol. So a variable access can get a type. Symbol. So what is this type symbol? Well, this type symbol may be a pointer, right? So temp node may be pointer. So we would have to say get type integer from types environment using type symbol. Yes and no. So we can't get an integer anymore. It's no longer a type integer. Get type node from types environment using type symbol. Yes, but it also, okay, so we're gonna have to say this. I can't do that. I'm gonna have to say this. I have temp node. I'm gonna say node pointer. I guess I also have type I could deal with. Let's see what I can deal with. Let's see what I can do. So the idea would be that the type symbol should be equal to temp node. So while temp node children I guess I should say type equals temp node children. While type. Okay, now it's making sense. So on the last case, we will set type to temp node children, type children. So in the last case, we will say type is temp node, type is temp node child, type is temp node child, until type refers to a valid node, but the very child. So this recurses into the child. And then this type should contain so this type should contain that. So I don't really want to do this. I want to do a mem copy. From temp node, the size of a node. Yes. So we copy temp node into type. And then we say, while temp node children, temp node equals temp node children. We use this temp node as a type symbol to get the type node from the types environment. Right? And whereas before, yes, we have to recurse through all the pointers. And I should probably just count how many, right? So this, I should say like type is equal to node, but then I should say I have an iterator, which is equal to type. Okay, so I'm getting ahead of myself. We have a temp node. So we have what may be like this, an int 0, right? Or temp node may be a pointer to int 0. You can just say int as well. So this says get to the very bottom until you get this integer symbol, right? And the idea would be that we need to get this integer symbol and get the actual type node from the types environment. Like this. Right? But we have to search for integer. But then the type that we return should be this many levels of pointer in direction. But instead of with the symbol at the end, it should have the instead of the symbol at the end, it should have the actual type information. So then we want type to be pointer with a child of int 0, like that. So to return this, then we should say copy type, then keep an iterator to type, which we can do with type itself. And say while temp node children, temp node equals temp node children. So temp node refers to the same memory that type does. It just refers to the very bottom one, and type refers to the very top. So then we can just say temp node is equal to, also this is going to break things when we free temp node, this little ditty. So this should be like an iterator. That we don't free. It's just assigned to something. So we copy from temp node into type. I think we can still do this. So copy into temp node is this, type is this. And we say iterator equals temp node, while iterator children, iterator equals iterator children. So now this iterator should point to here, this symbol. And we will get into type. We don't want to get into type. We want to get into iterator almost, right? I don't know if that's going to break things. And then we have to say that, okay, or, right, we could go back into temp node here, because temp node just pointed here. Type got copied, so, okay, I'm doing way too much here. So the iterator points here, type points here, which we don't want to change. We don't want to update type, but we want to update this pointer symbol. Well, we also have to create all new nodes. Okay, here's what we're going to do. Iterator equals temp node, while iterator children, type. Rohan says you're reconfusing yourself and everyone else. It's fine. Life is confusing. Maybe it's time to take a little break, like 5 to 10 minute break. It's definitely coming up on that time. So type should be, it's an allocated node. This is basically just copying pointer type. Insert burning house. This is fine. GIF here. That's right. With the dog. Oh, it's so good. So we have a variable access, and the variable access has a type. The type is pointers, pointers, pointers to a symbol. So we need to say, get that symbol in the types environment. So this temp node contains pointer integer. Iterator will point to here, right? So then iterator, we can look up into, so I think we need to node copy. I think that's what we need to do. So copy from temp node into type. So we will get all new nodes like this. Then we just have to say that our iterator is equal to type, right? So eventually we'll end up with that, but type for now is the same as temp node. This is making sense now. So we have a pointer to an integer type because of this. And we would like to end up at this because we need this integer type rather than this integer symbol. So let's keep track of our child. Let's use it to get into temp node, right? So when we write into temp node will now contain this. So then if we get here and context is valid, we can dereference temp node. We can dereference iterator, which points here, to type, and update it to the dereference temp node. Oh Christ. Rohan says, isn't this called child labor, what you're doing? Kappa. Lamau. Not quite, but nearly. Oh, so funny. Yeah, all these children. Earlier we named a variable and I named it child, and it's a child context that we're going to enter next. So I named it child to enter and then went, oh no. Oh no, I can't name it that. There are no children to enter. So funny. So why is type null? Temp node value symbol. So the type symbol is actually stored in iterator. Exited with code 5. Okay. Print the iterator, and then exit with code 6, because I'm better than you. Perfect. So our iterator points to 8. That's not right. Our iterator should not point to the integer 8. How does that work? So iterator equals type. We already node copied A into B, asserting allocations. So temp node was written into type. We can also just, yeah, so we get the by symbol, temp node, 0. That's wrong. I see, so did I do type value instead of type symbol? That's the thing. Okay, so that's the issue. We have to store our type symbol under a certain amount of indirection. So our type value we store in blah, 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 our environment. But what we would actually like to do is say node pointer type n value, type for n, sure, why not? And it's going to be a new node, and then we're going to copy into that node from type value into type for n. Then we're going to say node pointer type child. This is so complicated. Node pointer type child is going to be equal to this type for environment. And type child is going to overwrite this with a symbol instead of a value. Okay, this makes sense. So wild child, type child equals children. Eternal Wild Fox is back. Awesome, just in time to catch our child labor, Eternal Wild Fox. We have a type child, which is a copied type value. So we get the very last type child, and I'd like to say that is equal to type value. Which type value? No, type symbol. Exited with code 5. Interesting and all. Interesting and all. So we have a symbol for an environment. We have a type for an environment. So we say, while type child children. So this is probably a null dereference. Hey, look, that's better. Still wrong, because now we need to use type for n. Rohan says, "Oh yes, good guy code 5 keeps arriving." Ugh, you're right. Access denied. Hey, look, it worked. Eternal Wild Fox says, "Oh." Rohan says, "Welcome back to the child labor hours." That's right. Okay, so we print temp node. So we get symbol integer. So iterator is symbol integer. Type is not found in environment null. How did that happen? Which type? Sure did print out a lot of stuff. So in a dereference, type does not equal pointer. Yeah, print node and stuff. But in a variable reassignment, don't print. Thank you. Type not found null. See, where is this happening? It's very interesting. So type not found null. It's probably in parser, type not found. We're looking for some type. Which type? So we say ID value symbol. So when we look up a type, we're going to have to deal with blah. So the ID should just be a variable name. So where do we call parse get type? Rohan says all types. That's right, together. Oh, this is annoying. Okie doke. So we say parse get type of what? A function call has iterator and temp node, so this is parameters. And while we loop over these parameters, I think we do all this to do, by the way. So while we loop over these, we say what? Parse get type of temp node children next child. So temp node is equal to value, which is equal to our function. So temp node contains our expected return types for these parameters. So let's just see if this is where it's happening. I don't see here, right? So it's not happening there. This is going to be rough. So we parse get type, blah, blah, blah. And then we get the expression return type of iterator. That seems fine. Okay, what else do we do? What else do we do? Parse get type. We also parse get type. Get expected return type of left-hand side in temp node type. That seems pretty valid. So temp node should be integer. Get return type of left-hand side. So we get the expression return type, the expected return type, and move on. I had to just screw it up somewhere. So parse get type. We have, oh Christ, why? So we have parse get type, context temp node, temp node. What is this meant to do? This is where we're in code gen. That would make sense that in code gen we're screwing things up. So we parse get type. See, I don't get how we get type not found error and then exit finished. So let's make sure that our grep, did we do error equals on all these? All of these have their error handled. And right away, if error.type. If error.type. Okay. So temp node contains a function node. Parse get type of the type symbol. What is this? So we're getting into type, the return type of a function call. Yeah, so that we just get the function node and then get the type because it's a symbol. Still type not found null. So let's see if it's here. So we're just going to print whatever this is. And print here, hopefully. So it's not this parse get type. We now know. Not here. This is the case of a debugger. We should probably just use one, but it's going to be quicker just by searching. There's only like 8 cases. Unless it's in none of them, and then we're going to definitely be confused. Still no here. So in your YouTube video, will you add a type counter throughout the video with a total at the end? No. I can't do that much editing. Feel free to, though. Never once here, huh? So where are we returning from parse get type? And returning an error, but not returning an error. This is so weird. So we're not bubbling up an error somewhere. I mean, it's only called in one spot. And we get the type of the type symbol into the type value iterator. Seems pretty valid. And if we look at code.s, yeah, it looks great. It looks great. Why is this so bad? So we have foo with a variable declaration a, and then we have some major issues that happen. So maybe it's in CodeGen. So for a variable declaration, we parse get type of what? So what is this? CodeGen expression? So let's just make sure that we say error equals on everything we do. We do here. See here, we don't actually check for the error, which is a big problem. Checked, checked, checked. So now we check for errors in every scenario, in every case. Okay. Still not quite clear where this is happening or why. I'm not sure why we're getting this stuff printed out. Like, why is this being printed out? I want to print the current context out. Why? This is annoying. Lots of fprintf, yes. Not at all. Rohan said, error is hiding, as I said earlier. Lamau. Eternal Wildfox says, I was looking into your data struct again, but yours makes more sense memory-wise. Yes? It's just fairly efficient memory-wise. We're still going to change allocation, but It works out. It works out. So we get all the way through CodeGen, but CodeGen creates some very odd stuff. And it's acting like this variable declaration is what's causing everything to stop, right? So maybe in CodeGen, when we do global, well, no, it's not global. Right, so no matter what, we return the error. Rohan said, or I already read that. Eternal Wild Fox says, but for a VM, I am not going to use an AST. I meant for compiling. I see. Yeah, for a VM, you won't need a syntax tree. You just need a an API, basically, that can take in an opcode, right, with operands, and then executes them. And then you just need to make a way to read those opcodes from a file or something like that. Okay, okay. Eternal Wild Fox says, indeed, opcodes. Yes. So error equals, and we return it. Everything seems fine. Okay. CodeGen program. So I think I can do this. Would save a lot of memory allocation for global variables. We say error equals. Maybe this is where it's happening. Hey, look, that's where it was happening. So in CodeGen function, we're doing something wrong. Or at least we're running into an error somewhere, which is type is not found in environment null. So how many times are we here? We're here once. We're finally here, boys. A is an integer 0. So then we CodeGen the expression, and it says type not found null. So what's the expression? It's a variable declaration of the symbol A. So variable declaration of the symbol A. We get thing into, yeah. So we get the environment variable. I'm going to do this so it's a little easier to read. We get the type of the variable. So then this will contain a bunch of pointers. But we need to get the size. So we should say if temp node type is a pointer, see, we need to get the size in bytes of the type of the variable. So a pointer is just going to be 8 bytes. Then that means that temp node, so if temp node is a pointer, then we would like to say something else. So let's say size in bytes is 0. And here, size in bytes is hard-coded to be 8. Yes, that's how that will work. Indeed, indeed. Otherwise, try and get the type from the environment if it's a pointer. But a pointer is always 8 bytes. And then we just need to say parse get type, blah, blah, blah. Temp node children value integer. So for dynamic types, like user-defined types, we need to get the size or calculate the size upon creation and store it in some table. And this is where it's been stored. So now our size in bytes is equal to this. Haug. Yes, yes, everybody. Ooh, it's so late. Okay. I definitely have to go. I'm going to get some royalty-free music going. Feel free to stick around or go. I will make another mini announcement in the Discord, in the general chat, and I'll say, hey, I'm back, if that makes sense. We are going to have, okay, what's like a long-ass song? So we're going to do this one. And then we're going to say, okay, listen on repeat. Thank you, everybody, so much. Rohan says, at least test if it works. Don't leave us hanging now. Okay, you got it. It doesn't. So, I don't know why that doesn't work. Because we shouldn't call parse get type if it's a pointer. So I'd like to print node, temp node, 0. Time for /fix me later. Lamau, you're not wrong. What is this? So print node temp node. So the variable points to a pointer, then we should just say 8. But it's not a pointer, it's an integer 0 with a symbol child. How does this make sense? What is this? What? Okay, so could I please print the parsing context? So in the parsing context, could I print things a little more? Print parse context. Oh, Christ. So then in an environment print, and then this is going to be node print node with 0. I don't know. So the problem is we don't do children and stuff in the environment, so it makes it kind of difficult to see what's going on. Because symbol pointer should point to a pointer type, but this says integer type. So I'm very confused as to what's happening. And annoyed. In any case, okay, time for fix me. I'm going to go to the scratch and say, hey, small brick. Oh, screwed something up. And then we're going to say 5 minutes or so. Sure. How about that? You good with that, chat? All right, let's start some music and mute me. Bye, chat. Be right back. 5 minutes. made it. I'm sorry, everybody. Hopefully that was not too long. Small definitely broke, Lamau. Oh, Cyber Patty, you're so funny. Rohan says, this screen also calls for a fix me. So my zone program started running. That's hilarious. Oh, Christ. Okay, we're back. I said I would put a message in the Discord. Hey, Waffle. Hello. Hey there, Waffle. I'm back live from my break. Oh, I didn't do that right. Perfect. Rohan says, welcome back. Hey, it's so good to see you, Rohan. He says, PogChamp. Hell yeah. PogChamp. I'm back. Let's get this shit. Let's get this shit. Let's get this shit. So I would like to say, while okay, so I'm gonna have to do like binding iterator, right? So binding iterator is actually points to a node value. So this is going to be value iterator. I'm going to say while value iterator. We're getting right back into it, folks. Thank you so much for the welcome back, Rohan. We are getting back into it. We are currently working on printing out our debug printout of environments. It needs to be a little better. So that's what we're doing. So we're going to loop over value and all of its children. So I did this a little bit backwards. We still need to do that. Then we need to say while value iterator, print a new line. So every time there's a child, print a new line, print the same amount of indents as before, plus 2, right? So we're going to have to reset indent iterator. This is why we made it an iterator. So we have this indent iterator, but we would like to make it plus 2 because it's a child, right? And then we call, it's not another binding, it's just another node. So we would just like to print out something like this. So maybe we'll print out the same indent and then have an arrow at the end. So that would end up with like node and then child, stuff like that. I think that's understandable. Hey, look, I screwed up. Woo! Does anybody catch that? Oh my. So then we're going to say that's much better. It's not correct, but it's much better. Because we would have to know how long ID is. So we are just going to do indent plus 2 and then do like this. I think just like this. Look, we got infinite iterator. Yeah! Grammar to Parser Boy says, hello, I've implemented array allocation today. I am so happy I make progress. That's awesome, Grammar. That's very cool. If you don't know, Grammar to Parser Boy is working on backlang, his very own language, which is very much more mature than mine. So he's worked on it much more and is much better at it, I would say. So these symbol equal point to none, which is interesting. I didn't think they pointed to none. So that's because we're getting node text on binding value still. But what we would like is to get the value iterator. There we go. So now we can see operators have precedence and return type symbols. We can see that types have sizes. Very cool. Very cool. And Grammar2 Parser Boy says, if someone wants to help, I am looking for people to implement a chip 8 backend. That's so cool. Whatever he's doing, we're probably going to be doing in 3 months. Can almost guarantee it. That's how these things tend to work out. So function returns an integer with... Hey. Oh man. The kitty is in the room. Oh, I know. All right now. Okay. Good girl. Christ. Should have muted for that one. That's going to come back to haunt me, isn't it? In any case, the cat is gone. Hey, I got a follow while I was gone. AO Cypher, thank you so much for the follow. I very much appreciate it. Welcome to our Epic Compiler Club. Rohan says, you wouldn't want my help. Would be more work to get to the point until I understand all of that than you doing it yourself. But it may be fun. So a pointer points to integer 0, and that makes no fucking sense. So let's fix that. Why point to integer 0? Parser, you're probably causing all these issues. So pointer, I really need to make some comments where the pointer stuff is. Okay, so I guess it would be dereference. But it's not. It's going to be variable access. Because then we check, okay, variable declaration. Because that's where we check for type. Variable declaration. I'm probably overcomplicating this so hard. That's usually what I do. If you didn't know, I'm the overcomplicated guy. Grammar2 Parser Boy says, implementing more than 2 backends simultaneously is impossible to handle. Yeah, you can't. I think that would break someone's brain. I think that may be programmer torture. Like, try and make them learn, like, write a program in JavaScript, but also in Python, but also in C, but also but all at the same time. So if you write a function in one of them, you then have to write the function in all the others. It would be like, this is horrible. You couldn't make any progress. But you're right. If you just choose one language and one program, you can get it done. And as far as backends go, that means you can choose one backend, but further than that, it gets complicated. So we create a pointer and then Lex into the child. Yeah. And then we get a type symbol once it's not a pointer declaration symbol. Once it's not a pointer declaration symbol, then we... Okay, so the idea is that type symbol contains the symbol. So this is wrong. This is wrong right here. Folks, did we find it? Why are we doing this? Why are we doing... Hey, my goddamn... It's broken again. My comments aren't going gray. Emacs, what's going on? That's so weird. I've never seen this. This is the first time I've had this issue. And I didn't update anything, so maybe it's time to update. So, parse get type, blah, blah, blah. We have a type symbol. While we're parsing, we need to check if it's a valid type. And also this is wrong. This check. So we're just going to create node pointer type value. Because type value, that goes type value for environment, which is what this is. This is type for environment, I promise. And then we can just say, if I'm wrong on this, it's going to suck, but I'm pretty sure I'm right. And here's the thing. We're parsing, so we don't actually want the value of the type, do we? Oh, we do, because this is a declaration and we have to set it in the damn environment. So we also need to add it into the, okay, why are we doing this? Grammar2 Parser Boy says brain is restarting. Rohan says just restart the program to fix it, Kappa. Lamau. My brain has definitely been restarted. In any case, let's think about this. So we have a variable declaration that we are trying to parse, and there's a whole bunch of stuff to make sure of first. So the first thing would be to make sure that we, first of all, have a valid type. Why do we need the type? We need the type with any amount of pointers. So we need like the pointer to integer, for example. We need this type because this needs to be stored. Why did part of it get updated? I don't know what's happening. I think because the file is over 1,000 lines long, I think Windows Emacs is choking. We got to split it up, boys. All right, so we have pointer integer. So this is going to be variable value and variables environment. But then we're also going to need to what? I think that's all we need. Why would we need anything else? We're just parsing. We need to make sure that this type is a valid type. Okay. So we need to make sure that we can get this type, but we don't need to get it into anywhere specifically. Meaning, we get this type symbol, we parse get type and make sure it's not none, but this just needs to be into a dummy location. So this is like unused type equals node allocate free unused type. And then we're going to do some more lookup. Invalid type with invariable declaration. What was it? God damn it. That's not an invalid type, I promise. So now the issue is that we have to say unused type here. So it's not unused type. We just should say type validator. And then free that after we use it, please. Don't dereference a freed node. We advanced the errors. We advanced the errors. So it seems like we're getting less errors than before. I hope. And we're getting a lot more debug output for some reason, right? So let's check the type checker. These are contexts. So where are we printing context? In every variable access. Look at that. Okay. So now don't do that. There's less output. Okay. It's starting to make sense. It's in CodeGen where here appears. And here is within where. CodeGen function. So in CodeGen function, we were having issues getting the type because our parser was creating a bad boy. Then we're also printing the node. So why are we printing the node? I don't know. Every body node of a function we were printing. Okay. We now have sim integer. I don't know what that's for. We have to-do address of. That's probably true. And we have internal compiler error. We should deal with that. Right? We should deal with that. Because we probably didn't just write that willy-nilly. local variable access in symbol to address, we're trying to access a local variable by a symbol. What does this even mean? Okay, so we're trying to access a variable in the locals environment with symbol as the ID, that's our search node, and then our result node is stack offset. And then with stack offset, we set symbol index or whatever. Okay. And the issue is what? We're getting internal compiler error, so we did not get this local. So what are we searching for? Let's make this a little better. So we're gonna say error symbol to address, right? And then we'll say something like could not find in locals environment. And then we'll give it a which is what? Symbol value symbol. None of that internal compiler error nonsense. Okay. Could not find null. So that's a big deal. Could not find null in locals environment. That's a big deal. But could not find putter. That's confusing, but maybe we're just not entering the correct context as we go. So you can see that we have this context with these operators and functions. Then we have down to here. Then we have this child context, which is our function scope. Rohan says code 5 is outdated. That's right. We complete with memory errors, right? You failed successfully, right? That's how we do it around here. Could not find null. So symbol to address, where does it get called on? Expression children of a variable reassignment. Haha. This is not necessarily the variable name. So we now need to find the variable symbol. Right? I think that makes sense. So the problem is we're calling symbol to address on a variable reassignment, and we're trying to get the address of the right-hand side, but it's a like a dereference, right? Or an address of on the left-hand side of the reassignment. It's probably a dereference in our case. So this dereference, we basically just have to find. Okay. Rohan says, we're getting there. Ah, yes, that's a new one. How is everybody doing? I would like to thank you so much for sticking with me through my little break. It helped so much. So expression children. We need a node pointer, but we can't do that. So we're going to do like iterator. And then we're going to say, while iterator does not equal, well, iterator type does not equal what? Variable access. Iterator is equal to iterator children, because a reassignment can now have dereferences on the left-hand side. Variable name symbol, that's our iterator. We'll end up pointing, so our iterator will end up pointing to our variable name symbol, which we will use down here to get the symbol to address. Exited abnormally with code 5. It was outdated, it's back again. Oh boy. While iterator. Children. We're getting better. Code 5 is back. Pog. We got Pog Bones from Rohan. Hell yeah. Love that emote. Could not find putter in locals environment. What is our locals environment? Could not find the. Is that what it is? No, we need code. I don't think we have a codegen context print, do we? So we could do an environment print on the codegen context locals. And we're definitely going to put a new line here. Interesting, interesting, interesting. What happened here? Because I would venture to say that that's incorrect, you know? So, that's very funny. That's an interesting value. Yeah, very interesting. It's also, there's something else. Putter exists in the environment. Never gets boring here. Nope. Oh, Christ. What did I do? And it says could not find putter when it's clearly the first one in the list. Oh, no. What have I done? Oh my God. Okay, so we're doing a local variable access because we have a local variable declared A, and we have a local variable declared putter. What did I do? We're trying to get a stack offset. You're searching the wrong environment. But I'm not. Maybe. Let's look. So environment get from locals. Searching for a putter and a kappa. Lamau. Rohan, you're hilarious. Never change, Rohan. Never change. So we print the environment that we don't get from. This is the same environment. I'm almost guaranteed. So the problem is what? Symbol value symbol is putter. So let's look for environment get, because maybe it tries to match type, right? Node compare, binding it ID, so it does, it just uses node compare. And here's the thing. Here's the thing, we get it now. There's a bunch of to-dos in node compare. Is there not? There is. Is there any that are not handled? We have reassignment, which would print to do. Do we have any to-dos? We just have to-do address of. So we're here. You're telling me we're here. So we environment get symbol. What is symbol? Can I just print the node of symbol out? What am I given? Because it may start making a lot of sense. Okay, it's starting to make a lot of sense. Rohan says to do. Nah, we only have fix me in here. You that different type of programmer. Hey, it's different this time. That's not great. This is really not great. Oh, crap. So symbol putter, integer, wrong. Very wrong. In any case, we'll fix that later. But we have the symbol putter. We should be able to get it. But we can't because we're using types. So a variable access. Here's the thing. Isn't a variable access... Oh, I did that wrong. Much easier way to do this. Isn't it the same as a symbol? Effectively. I mean, it's just got a symbol. Still says could not find putter. So what if we first switch on the type, then we return 0? Right? I think that's fine. Because type equals type doesn't really work anymore. So if a is an integer, so here's the problem. We're treating both of them as the same. It's an even bigger negative integer now. Yeah, I don't know how that's working. It's even bigger. Oh no. Chat. Chat, help me. It's never gonna stop growing. Okay, so could not find symbol putter in locals environment. So if a, we're just gonna add the special case and say, excuse me? Why is my indent broken? That's annoying. Okay, whatever. It doesn't matter. If a type equals symbol or variable access, run it 2 more times and you'll overflow it to +1. Lamau. Why is my indent not working? Emacs is very unhappy. I'm not sure why. Seems like it'd be fine. Am I even in C mode? Hey, look, that fixed it. Chat. Remind me to do that in the future. I'm gonna run it 1 more time. Oh nope, it's even bigger. Chat, it's even bigger. Oh my god. It's negative 19 billion or something. Rohan says easy fix. So if both of these are equal, right? So if they're a symbol or variable access, and either one of them is one of them, if that makes sense. So we have 2 sides, A and B, and each A and B can be 2 things, a symbol or variable access. And this whole thing, we would like to say, if that's true, don't return 0. Continue on. So we're going to say if not that, right? We're going to say if not that, return 0. But share same comparison. Perfect. We could also just copy it and make it a function, I know, and it would be much easier than whatever this is, so don't at me. This is the ugliest thing ever. So basically, oh, this isn't going to work either, man. So when we do this check, we have to first check that this is not true. So we're basically just going to have to put this in here. I think that makes sense now. Okay, so if our... This is a terrible fix, by the way. Do not do this. You know what we're gonna do? We're gonna be that way. We can't do that either. No, that won't work. We just need to make sure A and B are the same, or can be treated the same. So we're gonna say if A type is symbol or variable access, right? So from there to here. And B type is a symbol or a variable access, and not that. So if A, okay. So if A and B are not this matching this criteria where they might be the same, or they are the same, then check and say, okay, the types we can just check. But if the types are the same, then we can just treat them the same. Please. Oh my god, it worked. No, I don't know if it worked. We're getting less errors, though. Much less errors. We just weren't able to compare variable accesses and symbols, but we were trying to. Now we're saying symbol integer and to do address of. Where do you think that is? Do you think that's here? I don't think it's here. Okay. It is here. We have to do dereference and to do address of. Where were we? Weren't we doing reassignments? Weren't we doing type checking of reassignments or something? I don't think we did that yet. Yeah, we did not do that yet. So we now have, we get type of left-hand side variable dereference adjusted. We're just going to print temp node out. Alrighty. So we have symbol null. That's not exciting. Why do we have symbol null? When do we have symbol null? So I'm going to do this. That way we can see how often it happens. So we are here in printing symbol null. How does a variable reassignment have symbol null as the left-hand side? Well, here's the thing. The left-hand side may be a dereference, so the symbol may be down under, as they say. So we're gonna have to get like iterator is equal to variable name symbol or whatever, right? And we're gonna say iterator is equal to expression children. And while iterator children and iterator, yeah, let's just do while iterator children. Let's go to the very bottom for now. This is horrible, by the way. We're gonna end up rewriting the whole compiler in like a week. Once I know how, once I figure out the final like structure of everything and how to do it, I'm gonna be like, I can fix this. It's gonna be glorious. Or I'm never gonna do that. I'm just gonna move on and leave this behind, which is also just as likely. Rohan says, time to dive deep, lol. That's right, we're diving deep. So iterator now contains, well, I guess we want to handle this in expression return type, don't we? Well, yeah, let's try that. We're gonna do that. We're gonna leave this how it was. And let's try and get the return type of a dereference, right? So let's print node type. So dereference return type. Where'd we get? Int 0, int 8. So we got the literal value of the type in the types environment. I think that's what we're supposed to do. So we got here simnull, here pointer int 0, int 8. How does, okay, interesting. Dereference return type integer 0. So to compare the return types, I don't actually need them as this. I can just compare return type symbols as well, as long as we have type checked that they are valid symbols. So when I dereference the return type, no, when the dereference return type. So dereference is an expression here, and it's saying return type is integer 0, which is exactly what it should be, right? But we need to handle this differently. So dereference here, what this means is that get the symbol at this address and then write to there. No? Yes, so this means read the pointer value. Whoops. So dereference means read the pointer value and get the integer that is there based on the type of the pointer. So in type checking, a dereference, we would like to say, also here, we're going to do this for now. Just make sure that I'm not messing things up. Still have symbol, integer, and to-do address of. Two things to deal with as well. Okay, what do we got? Dereference return type. Because we need to get the return type of a dereference. So all it is going to be the return type of its child, but with one pointer on top of it. Which is exactly why we see int 0, int 8. Because there's a pointer. Yeah, this is starting to make sense. So we type check the dereference itself to ensure that its children are correct. No? Dereference. Get the return type of its child and ensure that it's a pointer. Yep, that's it. Dereference may only operate on pointers. Perfect. So we ensure that the dereference has a pointer child. We then check that the child expression is type checked. So if it's a dereference child, right? Then, oh Christ. So if the dereference is a dereference of a dereference like this, and we ensure that that expression has children that are correct. Because we don't do that when we type check the top level dereference. Well, we don't get top level dereferences. They only happen in cases of reassignments generally, in which case they're a return type value. Oh boy. Oh boy. So how deep will the dereferences go? Infinite iterator time, Kappa. Yeah, they'll go as deep as you want. That's the point. It'll be like C. You can have as many pointers to pointers to pointers, but the only way to create them will be with the address of operator. And the address of operator won't allow multiple address of operators in a row. So you'd have to create variable A is a integer pointer, is an integer, right? And then you'd have to say variable pointer is a integer pointer. Pointer equals address of A. And then you'd have to say pointer pointer is an integer pointer pointer equal to the address of pointer. And then you'd have to chain them together like that. if that makes sense. So you'd basically, it's like here. So to make a pointer, right? The only way to create it would be like this, and then the only way to assign to it would be like this. Because you need an already existing variable that has been declared. We're not doing raw pointers, we're doing pointers that are references. They're not strong references. Pointers will still be able to be null. But they the only way to create them, like actually correctly type check them, will be like this. You'll have a pointer, which is a pointer to an integer, and it will equal the address of a variable, which is a pointer to an integer, which is effectively what that means. But yeah, that's the idea. Not for now. We're working on just getting this crap working. First time chat from a new viewer. Hater6969, what a name. Hey, you're doing cool stuff. I love language development. And Hater6969 with the follow. Thank you so much. I appreciate you joining our epic club of compiler nonsense. There's lots and lots of hours to go and watch. It is so good to have you. So good to have you. Alrighty, alrighty. Sorry about that. Just had to check my phone thing. So type checking a dereference. We're obviously not getting any return type errors. So what if we should? See what I mean? This shouldn't work. So that's because it's a reassignment and we're not doing anything. So we get the return type of a dereference. Let's say. And it says, see, this doesn't seem right. It seems like the return type of the dereference is changing. Hello? Okay, never mind. There is no dereference. Hater6969 says, I usually use Rust for language development and other stuff. By the way, is a type system hard to create? I still haven't tried creating it. You should go try. Hater6969 says, you seem to be an expert. I also seem to be a whale biologist, but I am not. So in fact, I am not an expert. I am some 19-year-old kid. Do not listen to me. Do not do this because you think it's the right thing to do. It's not. This is some crazy ideas of some kid, okay? Just to put it in perspective. This is not like, yeah, look at this professional doing work. Hater6969 says, lol. It's true though. I sound professional. He says, and I'm 16. Yeah, there's definitely better people out there. You know what I mean? This is not like, ooh, write this code, this is perfect. I'm just saying this is a compiler that I wrote for fun. Rohan says, and now I feel old, dang it. Don't worry, I feel old. I think I only got like 10 more years on my life anyway, maximum. So I think we're in the same boat, if you're very old. But you probably have a longer life to live than me. Because I don't plan on living a long life. Why live long life when short life do trick? You know what I mean? Rohan says I'm 28. Yeah, see, you're an elderly man. You're so old. Hitters6969 says, are you using C? I am using C. From scratch, with no libraries, except for the C library. From the OS, of course. Otherwise, it'd be pretty hard to do anything, compiler-wise. But yeah, with no libraries, no dependencies. Just the OS. Cyber Patty says, well, in that case, we could already jump from the cliff with Rohan, or just enjoy the rest of the short ride. Exactly. That's probably the way to look at it. There's not that much longer to go anyway. Might as well live it out. The world's getting hotter. The water's gonna dry up. Hater69 says, you're saying some deep stuff makes me feel weird, question mark. Why don't you want to live? It's not that I don't want to live, I just don't want to live a long time. I think, why live long time when short time do trick? You know what I mean? Like, not... it's just not for everybody. Hater6969 says, have you tried Rust? It's much better than C. Oh, Hater. Don't be that guy. It's not better than C. It's just different. Go write a linked list in Rust and tell me how much it looks like Rust. That's just all I'm gonna say. So we have a dereference. And we want to type check it to ensure that it, to get its return value, we want to make sure that it's valid first. That makes sense. That way we don't miss out on this dereference. We want to type check its child to make sure that if the child is a dereference, it's also correct. Because then that will end up most likely back here, in which case we'll keep going down the children list. Hater6969 says, shut up, my friend teased me about linked lists, lol. Looks like you have written Rust code. Oh yeah, I've written code in Rust. And then the compiler says, no, you didn't do it right. Put a hash symbol here, or put a lifetime here, and then you put the lifetime in, and then it gives you an error and says, there's an invalid symbol here. The hash does not belong, or like, a static lifetime is not valid for this object. It's like, so there's just, the compiler is so strict that it doesn't let you actually write code that works, in my opinion. Because I like to just run code and have it fail. It's much easier for me to debug that way. Just having a program that sits there and has to be perfect every time to test it at all feels like it's not conducive to development. If they had a memory unsafe compilation flag, then I would do it. Like, if they let things by. Hater6969 says, I rarely use linked lists. Arrays and other data structures work for me. Then you're not used to low-level development. I think I just learned differently then. Because my first idea for everything is, okay, I can store this in a linked list with some data, and then I can expand this into a tree with children, or I can, you know what I mean? I don't have the whole other data structures in my head. And arrays can't be variable, unless you're talking about like vectors, in which case we don't have those in C, so it's not really comparable. You'd have to write your whole own vector class, and that's not really worth it. It's easier to write a linked list. And it's just as efficient in most cases, unless you're not iterating, and you're actually like doing searches through. In which case it should be like a hash table, but that's easy. Alrighty. So we have here symbol null. We should probably deal with this. Why do we get symbol null after saying here? So we have variable reassignment. So this should be here. So we should have pointer as our variable access, right? And we do. We have a variable reassignment of a to 0. So maybe that's what's going wrong? Let's take a look. In the parser, reassign. So it seems like if we happen to free the left-hand side, that would be a problem. but we shouldn't. We shouldn't. So this left-hand side pointer is pointer to result or the stack result. We copy from our current result into the left-hand side. We set our current left-hand side to, yep. So this should be like, I don't know what to call this. Result pointer? That may be better. I'm just gonna do that. It's a little more clear. But then we have a child left-hand side and a reassign expression. And this left-hand side is now owned. It's allocated and then owned by result pointer, which is either stack result or result. We never free our stack result. CyberPatty says, yay, I did my first commits for the new compiler. Progress! That's awesome! Did you post them in the Discord? I'll have to check them out. On the Discord, Waffle, someone who just joined while watching the stream today, it seems, says, oh, cool, I'm not watching the live, I found your YouTube channel. Oh, he didn't. He joined through the YouTube channel. Because I watched a lot of compiler dev videos. I want to catch up with development of your language, but I don't have 7 hours to spare. Fuck zodiac signs. What's your favorite sorting algorithm? Yes, GigaChad. It's binary sort. No, it's actually bumble sort. Hater says, I have worked with low-level code. I never needed it. Go implement a heap memory manager with an array. CyberPatty says, yay, I did my first commits. Oh, I already read that. Lamau. And if you're just going to tell me to use a new language, please, the door is on your right. Hater says, linked lists. Lol. So you understand why I'm a little confused. Weight sort. Ooh, that's great. This is awful. Brick. Len says, I'm not logged in on Twitch on my phone, but take this as proof I watched your stream briefly. I trust you, Lender. He's been in every stream. So did we get someone new? No, we just got waves. I love waves. Oh, there is someone new. Rohan. Hello, Rohan. Welcome to the Discord. Hater says, on my right? Lol. Yeah, usually it's in the top right, unless you're on Mac OS. So we have result pointer gets reset to 0, set the type to reassign, and move on. I still don't get how we get symbol null. So let's take a look at what temp node should be. So we're going to print something like this, temp node. And then we're going to print something like this, which is going to be something similar. And before you tell me to use a debugger, I probably will, but only after 15 minutes of fumbling around with printf statements. That's the rule. Temp node, symbol null. Expression children, symbol A. What went wrong? So get the return type of the symbol A. Okay. So we're not getting a return type of a symbol because it's not a symbol. We set the wrong type in the parser. Where? See, it's a variable access. So this variable access we create, right? It's here. We then create a reassignment. We want to say that it has a child of a left-hand side. That is this variable access. Or the stack result or the result, because that's what working result should be result if that's the left-hand side of this expression. Or if we're in a function, stack result will point to, again, the dereference and stuff like that. This is killing me. So the problem is that, here, let's just look again, because I have the memory of a goldfish. We have a null symbol in temp node, which means that the return type of, oh, I guess that's fine. Null symbol is fine. This is just a type. So this just returns a symbol. Why does this return a symbol? What returns a symbol? The symbol A. So this is a self-returning. Okay, chat. This is why I love C. I love it. Look, the default, we return the type, but we don't set anything else. So if it's a symbol, then we'll say symbol, but we'll actually have null on that side. Okay, so I feel ridiculous. The return type of a symbol is a symbol. Why do we have a symbol? Correct me if I'm wrong, chat. Left-hand side should be working result, because working result, I know it's at the very top here, working result, we don't need this, is set to result, unless we're in a nested stack, in which case we use stack result. Oh man. CyberPatty says, I have not yet published the repo to the Discord. It only has an error header file and a main file full of to-dos. That's what I have too. Same, man. Twinsies. But yeah, feel free to do it anytime. Or if you want to wait, anytime you are ready, is what I should have said. Feel free to do it anytime you are ready. So let's say we get a variable access. It's followed by a thing. The variable access needs to contain a symbol, which it does. So why do we have symbol? This is driving me a little bit crazy. So what's the type of the left-hand side is what we're going to do. So we're going to print node on the left-hand side. We printed with an indent of 2. I'm not sure it worked. We had variable access putter. Well, that's what we have here. Why does it think it's a symbol? To do, learn C. To do, language name, and language. CyberPatty says, to do, language name and the language. Rohan just added to do, learn C in front of it, which is hilarious. To do, learn the language that we're writing the language in. After that, name the language. After that, write the language. So good. Okay. So when we set the left-hand side, we know that it's a variable reassignment. What is this? It's here. I found it. I found it. It's the initialization. Chat. Oh my god, it's this. Who knew? Who knew it was this that was screwing us up? Oh my god. Ugh, of course. That was such... I almost clipped my mic on that laugh. That was so loud. CyberPatty says, I should add that too. I've coded in C++ as a computer science student a few years back. That's awesome. So you know quite a bit. So what's our left-hand side up here? A variable declaration uses a symbol, but we need a variable access. CyberPatty says that was an introduction to programming class though. Still, you know about for loops, while loops, you know about, like, usually they teach you basic in C++, like references and pointers and stuff like that. You've got it down. You're not just fumbling in the dark, like most people are, and myself. Working result type equals node type variable dec, a var decal. And then we want to create a var reassign right after if there's an initializer. See, we even have a fix me. So what is the left-hand side? The left-hand side of a var decal is a symbol. So this is fine. We're never gonna allow @putter as an integer. Like, that's not a good syntax at all, right? So symbol is gonna come first. Rohan says, oof, already 10 p.m. Time to go to sleep for me. Thanks for the stream, and have a great stream. Day/night. Lamau, thank you so much, Rohan. Concha. Thank you so much for tuning in, Rohan. I really appreciate it. Get some good sleep for me. It's worth it. The VOD will be up on YouTube if you do want to check up, or we'll probably be live again by the time you're up. Eternal Wild Fox says, time to create a dynamic array in C. Yes. It's totally doable. You only need like 5 API functions, right? Vector create. Vector destroy. Vector add. Vector pop. Well, you can't really do a vector pop that returns a value, but so you're going to need like a vector get. So you're going to need top and pop, and then you're going to need like at, right, for an index within the array, in the vector. And then you just need some sort of error way to like have errors happen. So you're probably going to end up passing like some error struct here, or just an integer with an enum, right? Vector is not an array. An array is much easier. What's the difference between a dynamic array and a vector? Tell me. Eternal Wild Fox, tell me. You said dynamic array. A vector is not an array, but Eternal Wild Fox, a vector is a dynamic array. So please tell me what you mean by dynamic array that is not a vector. Please, I encourage you. Rohan says, oh, I already read that. Ooh, activity feed, no. Oh, what does that even say? No, ND. That's hard to read. Nanananand. Is it Nanananand? It's probably Nanananand, isn't it? Thank you so much, Nanananand, for the follow. I very much appreciate it. Eternal Wild Fox says, okay, you're right. I know. That's why I encouraged you. CyberPatty says, lol, Poglang is not in use. Let me yoink that. Yes, Poglang. That's awesome. CyberPatty is making test.pog. Not a link. Don't click it. So funny. I don't even have it blocking links yet. We've been okay. I've been able to ban people specifically. I'm sure that's going to change at some point if I keep growing the way that I am, but I don't have that. On YouTube I have that because the bots are just fucking horrible over there. So even if we don't use left-hand side copy, we just should say this. And then type equals variable access. Right? And because it's been declared right here. So, you know what I mean? It's been set in the types environment. It's definitely a variable. We know this. The code has run, and it's validated with no errors. So we know that we can say that this is a variable access that is valid. So the parser is not feeding garbage. And then we just have to say that the variable symbol is equal to yeah. That copied. And then add the left-hand side. Bog. Chat, did we fix it? I think we fixed it, chat. Variable access A, which is an integer. Variable access pointer, pointer to an integer. Variable access pointer, pointer to an integer. That's not bad. Okay, can we now finally type check reassignments? We're going to have to do dereference adjustment. So what's the return type of the child? What is that? That's temp node. So the return type of putter. So shouldn't we have dereference putter in here? We have a reassign with dereference putter. We no longer have a reassign with dereference putter. Why? Why? Oh, just because I got rid of it. That's it. That's why. So variable access putter. Shouldn't we get variable access again? Because we should get a variable access that returns a non-pointer, even though we're accessing putter, because we dereference it. Oh Christ, this type checking is so complicated. Okay. So, okay. Where does here come from in the type checker? It comes from here. Let's try and remove that. I'm just going to do an empty new line. So every time we get temp node, and what is this actually in words so that I don't have to keep doing some like gibberish translation. Temp node is meant to be left-hand side return type. Dereference adjusted pointer type, right? That's what it should be. So then we're going to say left-hand side. We're going to print that out first. And then we're going to try. So the left-hand side is a dereference of the variable access putter. The left-hand side return type, dereference adjusted, is an integer. That's perfect because a dereference of putter isn't, yes, putter is what? A pointer to an integer, which means that dereference of it should get us an integer. Oh my god, this type system is working. So this is the dereference adjusted. This is no longer a to-do. We don't need any of that. And we just do that. Okay. Now we need to get the right-hand side. A right-hand side expression. So the return type of the right-hand side expression must match the expected type in temp node. So temp node now contains expected type. of right-hand side. Okay, yes. We're getting it. We're getting it. So now right-hand side is expression children next child. Oh God. Good enough for me. And the idea would be that the return type of this needs to be stored somewhere else. And then we need to basically say if compare type compare. I did type it right the first time, it just didn't autocomplete. So if we type compare temp node and result, and it equals 0 type error. What kind of type error? It's going to be one where variable reassignment, left-hand side, a variable reassignment must match right-hand side return type. Type of left-hand side of variable reassignment must match right-hand side return type. I guess. It's not the clearest. And now it says, hey, it doesn't work. So tell us the nodes that are incorrect, please. So I'd like to print temp node after saying left-hand side. And then I'd like to print result, the right-hand side. So right-hand side has integer. Interesting. So this is a self-evaluating value. So what we are going to do is effectively, also that debug worked out great, by the way. Just want to mention that I'm really happy with that. So the types don't match, but they do match. That's just because the return type of an integer expression isn't actually correct. What we have to do is say type equals, no, we have to environment get by symbol in what environment? Well, I guess what we're going to do truthfully is parse get type in original context, which is just context for us. But we're going to parse get type by symbol. So we're going to have to create a symbol and free it. So we're going to say iterator equals node symbol. Free iterator. I think we can node free iterator. And result, we're going to store it in type. We'd like to get from context the iterator, which is a symbol with what? This node symbol is going to be integer. So create this symbol just to look up here, then free it. But get into type and say error equals if error.type return type. Do that bubble up action, please. Exited abnormally with code 5. Okay. Mistakes may have been made. Interesting. So, interesting. Access denied. What happened? So get the type. Whoops. Iterator. So So parse get type. Parsing context. Okay. And it says, effectively, while context, environment get in the types environment, the ID and the result. So it seems like type will be written to based on the environment, or type will be none and their type is not found and there will be an error. But we didn't get a type is not found error, we just got bleh, big problem. Right? Yeah. So we're not in parse get type. We still exit with code 1. So what if we don't free anything? That doesn't help. So it has nothing to do with our iterator search. Parse get type. We'll get the type of iterator. So let's do like searching environment or something like that. Sure. Sure. Okay, searching context for blah. And then we're just going to print context, parse context print. Context. So we're going to do it from here. And we're going to say, okay, print out our context, please. And then exit. Looks like just fine one. Because its parent will contain what we need. Yep. Parent contains what we need. Type integer based on the symbol. Okay. So the symbol integer is mapped to int0, int8. Why don't this work? So we get some issue that didn't appear before when we had this. Is this correct? Yeah. So in my head, I was like, oh, all we got to do is make this integer not return itself like it is right here, but instead return its value in the types environment. But that's not working all of a sudden. Why? So where do we use integer? Maybe binary operator? So then we parse get type of, what is this? So we can get return type of left-hand side, get return type of right-hand side. We use expression return type to do it, and then we get the expected return type. And we say type compared to type node, temp node. And if they're not equal, we print expression, return type of right-hand side expression of binary operator does not match. So we have very specific errors for binary operators. So this is not a binary operator error that we are reaching. It seems like we are just dereferencing something that we very much shouldn't be. So let's try it out. Let's try it out. Let's see. in point. It says mismatch types, type of left-hand side of variable reassignment must match right-hand side return type. This integer isn't working. So you'd think that we would just be able to go up to integer and fix its little busted up case. Like this or something? And this will contain the size of an integer. Fix me. Look up in types environment instead. Exited abnormally with code 5. God damn it. Oh, this is so annoying. So why can't integer return type? Why can't it return a child? Why is it such a big bad deal? Right? Because I think it's not just about setting the type. We can set the type to integer, nothing goes bad. But as soon as we give it a child, we can give it a child even. We can give it a child, and it still doesn't matter. It matters when we set the type to integer, and then we exit abnormally. That's got to be in type compare, does it not? It does. Because look, I'm a dummy. Great. Great, great, great. Look, I did it, everybody. I wrote A instead of B, so I fixed it. And now it's working. Gotta love C. Dun dun dun. In any case, where were we? Reassign. Left-hand side. Okay, so we're a little bit further now. What's the actual expression? Right, we're gonna print the node expression. Right, then we can print the left-hand side type and the right-hand side type. So we have a variable reassignment with a variable access to putter. So the left-hand side type of pointer is absolutely correct. The right-hand side type is address of. Perfect, because we didn't handle address of. The return type of address of. We now can do that. Address of. And we would like to say, first of all, type check yourself. This means address of needs a variable access. So let's go write that one. I guess we're just going to have to, in type check expression, add our little case here. And we would like to make sure child is a variable access. That's the only thing that's allowed, I believe. So we are going to say if expression children type does not equal node type var access. Well, here's the thing. What if it's another dereference operator? What if we get the address of a dereference? Well, then we should just get rid of the address of a dereference. We just should get rid of. We shouldn't deal with type checking that. So we'll say that to do address of a dereference should cancel out. Perfect. For now, if it does not equal a variable access, you know what we do. We prep that error, then we send that baby off to to bubble up to the top of where the arrows can get printed out. This is a type error, and we would like to say address of operator requires valid variable access following it. I don't know how to say that right. We'll go with that. So we type check it, then we can just return, in which case we'll be right back up here. And now we can ensure that it's type checked. Now we can just say the return type is a pointer of whatever this thing is. So we're going to have like temp node. So we're going to say error equals what? Expression return type, context to enter. Whoops. Then we have, what else? Expression. So we would like the child. And we would like to get it into temp node or type or whatever. Yeah, let's get it in a temp node. And then let's say type is equal to, I guess I should say type equals pointer. And then I should say what? So after our type is a pointer, that means we need a child. So I should say node add child to type. That should be the copy of temp node. So we're going to say iterator with node copy. And then we can say iterator equals null. So effectively, mismatched types of the variable reassignment putter and address of A. The left-hand side type is a pointer to an integer. The right-hand side type is just a pointer. What happened? I don't know what happened. We should have added a child here. There's no error. Oh, we should say if error.type return error. Maybe we're hitting an error and we don't even know it. That's not the case. That's not the case. So the problem is that the right-hand side type, so address of type pointer works. But then, I get what the problem is. I guess we don't have result. So can I copy temp node into type? That's not really going to work. That's null. So we should say type children equals node allocate. And then we can copy. So temp node contains what? Return type of variable access. Yes, sure. So we need to create a pointer with a child and put the return type of the variable access underneath this pointer. Oh my. Did it work? Chat. Okay, we're gonna try and do something wrong. Oh my god, chat. We have type checking on pointers. Chat. Oh my god. If we dereference a pointer and assign it to an integer, a pointer to an integer, then it works. But if we remove the dereference and try to assign an integer to a pointer to an integer, it says, hey yo, buddy, that's very incorrect. Oh, that's so cool. Alrighty. What if I did like at pointer on accident? Oh, dereference may only operate on pointers. Look at it. It says it's operating on an integer. So this, we can get better at error messages, but this is Pog. So can we say a is equal to a dereferenced pointer? Oh, we can. And if we say, oh, it works. Chat. Oh, Lurker59 with the follow. Thank you so much, Lurker59, with that lurk. I really appreciate it. Oh my god, it works. Okay. Well, that's pretty awesome. Let's code gen them. Eternal Wild Fox says, good job. Thank you, Eternal Wild Fox. I'm so excited. We actually have like pointer type checking in a language we created for fun. It's so ridiculous. Node type dereference. Alrighty. So this node type dereference, we are going to have to figure out how to code gen. What do we need to code gen a dereference? We need to allocate a register. Like this. So expression result register is equal to register allocate R. Eternal Wild Fox says, I am so far behind in compilers. Oh, we all are. Like when Grammar 2 Parser Boy talks, I feel like my eyes glaze over and like my ears start to bleed a little bit. And I'm like, I don't get it. I'm too dumb. It's amazing. There's always somebody that's better. So just focus on being the best. No, I don't know. That's not good advice. Register allocate. So we allocate a result register. And we would like to then move. So first, let's, we need to say this. Code gen expression. Code gen context. Next child context. And expression children. Maconate says, me too, haha. Eternal Wild Fox says, gotta catch 'em all. Lamau. Okay, so we're gonna add a little message here. It says, hey, I am a dereference. I think that's good. I'm gonna do the same thing for address of. Okay, so now we should have, let's see, we should print some code. We want to emit code, and we just want to move the result of this into the result of that. So register name and R, and this is going to be expression. So I'd like to move from the children result register into ours. Right? Okay, what did that actually do? Oh, Christ. There there is still some very bad issues. This may crash if we try and run this, boys. Ooh boy. Maconate says, I try to understand everything, but it is not that easy. Trying to understand everything is kind of like trying to walk on eggshells. You may be able to do it for a little bit, and then it just goes, okay, you put your weight too much there, it's gonna crack. You know what I mean? You'll never know everything, but you can learn incrementally and know little bits at a time. You just have to be targeted with your knowledge acquisition. I sound like a tactical agent. Target the knowledge acquisition. In any case, we want to move into whatever the child is. We'd like to say, hey, wherever that is, please move that into our result register, and then that's our expression done with. With address of has a guaranteed variable symbol in it, a variable access. So all we have to do is say Leah on the address of. Maconate says, oh no, crash. Yeah, we're getting some bad data when allocating a variable declaration. So I think the problem, we're looking up a variable name, a symbol, and getting a type. And if it's a pointer, the size of a pointer is 8 bytes, right? But then somehow we're subtracting, the wrong thing. I fixed it, chat. Didn't even need printf. We're subtracting the wrong thing. This needs to be size in bytes. We went through and changed it. Perfect. Okay, hopefully, okay, the numbers are nearly more sane, but they are not. So now symbol to address is spitting out some very much nonsense for the stack offset. So variable declaration, we set in the locals environment the locals offset, which uses the codegen context locals offset. Which is a long. Everything should be fine. Here, we'll change this to a long, just in case. We still have some crazy numbers. Where are these coming from? So the locals offset is getting insanely big. Because once again, we don't use size and bytes. Okay, it's making sense now. It's making sense now. Hey look, those numbers make sense. -48 because of this variable declaration pointer. So -48 off the base pointer gets us to this variable declaration pointer. Wonderful. Very wonderful. We have variable reassignment of the dereferenced putter. So to dereference, we move the value at racks into racks. No, the value at putter, right? Because move will read this memory address, does it? So do we need to, let's get our little compile command going for this. So we'd like to use the GNU assembler, output to code.o, and input code.s. Also run ld, the GNU linker, and output code.exe and input code.o. And then, at the end, run code.exe. Succeeded with no output. So Ooh, look at that. So we have a variable access on putter, a dereference where we move racks into R10, and its child was a symbol, a local symbol. Then we have a variable reassignment, so the left-hand side result register, R10, is moved into A. Why is it moved into A? Well, that's probably what the value of footer was? I don't know. What is A doing here? There's so much going on. Can we make this a little simpler? Not really. We're just going to get rid of these and think about what this means now. This is much easier, right? So we have a declaration of A, which subs 8 off the stack. We have a reassignment to 0. Move 0 into racks, move racks into here. That's here. Perfect. We have a declaration of pointer, a reassignment to an address of. So this reassignment then does an address of, so we move racks into -48 RBP. That doesn't make sense. So we're not generating an address of yet, are we? That's what I would, okay. So let's try address of, so that this starts to make sense. Address of should basically say it has a child that is a, yeah, just recurse. What's the worst that can happen? Recurse on the child. And after recursing into the child, okay, so address of, if error.type. So we recurse into the child of address of, and then we would like to load the effective address at this register. Is that how this would work? I think this is wrong. We're going to have to use symbol to address in our current context on our child symbol. This is going to return a string. So this address calculation, we are going to have to use in an fprintf to our code. And it's going to have to be in a lee because we want to move this address into our result register. Is that correct? I'm not certain. What will that look like? I'm not certain. So hopefully this loads this address into racks. We then move racks into the pointer, and that's it. Succeeded with no output. So now if I go back to pointer and I say dereference pointer equals 4, and then return A at the end. And then I run it again, still succeeded with no output. That may be because it's never run. Exited abnormally. Invalid syntax, unknown symbol. What? What? That's not an unknown symbol, though. It's about to be handled in the stack. Parser, are you that dumb? It is that dumb. If not stack. We'll try that. Too many arguments passed to function. How many were? None? Well, that's confusing. We have none arguments passed to function. It's saying too many. Too many. So I think this is fine. If we have stack being null, then of course the symbol is unknown. There's no way it's about to be handled. All we're gonna do is break and return the error. But if there is a stack, then there's a chance that our unknown symbol can be handled as a stack operator or by a stack operator, like function calls somewhere here, having this dealt with. But the problem now is that invalid arguments, too many arguments passed to function. So our type checker, too many arguments, because iterator does not equal null. So let's print node of iterator and printf. What is this? All we know is this is iterator for now. So we're just going to go with iterator. We're going to steal that and put it here and then say temp node. That's all we kind of know. Iterator is none, while temp node seems to be null. And then we have function foo. I'm not sure if that has anything to do with anything. Oh, that's the arguments. So that's part of the error down here, function foo. So iterator, none. Temp node, none. But not none. So we shouldn't care if they are none. So each time we'll say while none p iterator, and then we'll say iterator. Well, I want none. I don't know. We'll see. We'll see. So the problem may be in parsing because our function has absolutely 0 parameters, but our function call always has an extra. So let's look at how we parse a function. Yep. So in our list of parameters, yes, we should do that, but we're not going to yet. So in our list of parameters to the function, we say forever, expect a closing brace. And if we do get the closing brace, then we never actually add the child and everything because we don't have the proper type. Is that true? Yeah, it's hard to create the parameter. So this parameter node allocate, all we have to do is this. And everything should be fine. Yep, perfect. Look, boys, it's fine. Oh, my life. Okay. Code 5. Access denied. Probably a null dereference. Why? I don't know. Just for moving this. I guess so. So we would like to add the parameter to the parameter list. The parameter list is an allocated node, which is a child of working result. We can probably do better on this. Like this. Add a child to the function, which is a parameter list. And where's next? the return type into working result function. And what else? Parse function body. Alrighty. That's better. Too many arguments passed a function. Still, we get iterator none, temp node foo. Okay, so the function call needs no children in the case of no arguments. How can we do that? That's kind of hard because of this little ditty here. Every time we check if it's a function call and look ahead for symbol, we get a function call, we create a child to parse into, which is our first argument. And then we continue and we parse into that. So if we continue and then just get back to our stack operator and get right to here, it's going to be different. So you know what we're going to have to do, folks, is not create a stack in the event that we don't need to. How about that? How about that? Okay, so if we make a function call, and there are no arguments, we do not need to create a parsing stack and then start parsing argument expressions, which means we do not need to do all of this even. Right? We're going to need the argument list, but the first argument we don't necessarily need. We don't need to update working result unless we continue. Stack. No, we're not doing the stack here. So if not done or not found. Not done, yeah, or not found. We'll do and, yeah, why not? Because if this is not done, then we want to check that it is not found. I don't know, let's go back. Let's go back to what we had. So the idea would be here, done parsing function call. What do we normally do when we're done parsing the function call? Right? So when we're done parsing the function call normally, we return stack handled parse or stack handled check. So we do we look ahead for a binary infix operator. And then we either parse, which would mean we continue, or we check, which means we, how do we check from here? This isn't really, we don't need to check. We should check that there are more stack operators to handle. Oh man. So for an empty function call, this problem is so simple, but it's so complex. It's so annoying. So we are done parsing function call. And we should say, look ahead for a binary infix operator. Which really just means continue from here, right? We often need to continue from here. I'm gonna write this. Note. We could use a goto, but I feel like that's not the way to go. But when we are here, checking would be the same as going down here. Because checking, as you can see, just checks for the handled stack operator, if not, blah, blah, blah. So effectively, we just need to break. So parse right-hand side of binary infix operator. And this is going to say parsed function call. Check for stack continuation. Perfect. Perfect. Current token. Token length. That's a pointer. This is a pointer. Iterator temp node symbol. Why do we print that out? Oh, we just print that out every time. So we still say symbol integer for some reason. Yeah, I don't know why we say symbol integer. I cannot figure it out. In any case, let's take a look at our generated code. Okay, code des, more assembly. So we have a function call foo. I get worried about this. What is that? Add 0 to RSP. No thank you. Code gen, what? Add 8 to RSP. Add blah to RSP. So maybe the locals offset was 0? No, it's after a function call. And then, yeah, see, we add count. So we should say if count. That's much better. No more add 0. Okay, so we now push racks and call foo. Why do we push racks? Just so that we can pop it again, no? Yeah, with this add 8 RSP. Just so that the return value from the function can always be stored in racks. Then, in foo, what are we doing? We are saying variable declaration a sub 8. Variable reassignment integer 0. That's interesting. So we are assigning a to the integer 0. We move 0 into racks, then we move racks into where a is. That makes sense. We declare a pointer, and then we reassign, get the address of, so this is a reassignment to pointer. So we load the effective address of this into racks, and then we say racks -48 RBP. So this should move the address in LEA into putter, thanks to this reassignment. So variable reassignment, integer 4. So then we assign 4 racks, and we move that into -48 RBP. That's incorrect, isn't it? This moves 4 into pointer, so our dereference seems like it's not working properly. And it's probably just because I wrote it wrong, don't get me wrong. So we just say generate its child, and whatever its child result is, move that into your result. And the idea is that type checking has ensured that the children of a dereference are only, as we can see, variable accesses or more dereferences, right? So when we code gen a variable access, we're not going to be able to do this directly like this, because codegenning a variable access will move So let's look at point. We would like putter, which points to a, to be assigned to 4 dereferenced, which means that a should be equal to 4. So to get the address of a, we are going to need to load the value of putter. So how do we load the value of putter? We have to LEA. Don't we have to do this? We have to get the address of the pointer, right? So the idea is that code.s dereference. There's not a single dereference in sight. That's not a great sign. Right? That's kind of confusing. Tell me there's no dereference. There's a dereference here after the variable reassignment of footer. So let's see, we have address of, and then we have a reassignment of 4. So let's look at how we type the code gen reassignments, because I'm sure we're doing it incorrectly. So we get the name symbol of the right-hand side, right? Interesting, interesting, interesting. Should we not just code gen this side, right? So expression children, we should just code gen it, I feel like. This is a little ridiculous to have iterator and all this stuff, when really all we need is to code gen and then use the register. Okay. Yep. Once again. Okay, so we're going to code gen it first, and then we will end up with set of symbol to address on iterator. We will have register name of expression children result register. So the result of a variable reassignment will be what? The result of a variable reassignment, I don't know what that will be. To do, set results register or something. For now, let's try it and see what it looks like. Hey, this is better. So now we have a variable reassignment of A. And A we move into racks, right? But the problem is this just gets the value of racks, right? This gets the value of racks, or of A, the variable. Whereas we want the address, do we not? Because racks, we then do what? We then just move R10 into racks. That's a little confusing. So we move 0 into R10. So that has to be the result register thing happening. Interesting, interesting, interesting. Okay, so I wish I was less stupid. So if we just access a pointer, or if we just have a variable access, we would just like to move it into move the value of it into a register that we can then use, or the pointer to the value of it, or whatever. So if the left-hand side is a variable access, then all we have to worry about is, okay, so left-hand side of a reassignment type is a pointer or dereference or something like that. So that's not going to work. So if the left-hand side type, how can we do this? So a variable reassignment, if it's, if it's not a variable access, then we'll code gen. Else, what we're going to do is say, okay, this reassignment, hey, Sun3, thank you so much for the follow. I very much appreciate it. We got that lurker follow. Thanks for lurking. We really appreciate having you around. So, if it's not a variable access node, then it's probably a pointer. So, code gen it. We're going to need dereference and stuff. Otherwise, what did we have here before? We're going to check git. We are in codegen.c. We're on line 560. So it looks like here is where it would be. No? Yes. So before, we just set result equal to register name. Is this related? Interesting, interesting, interesting. So for variable reassignment, seems like this is right here, yeah. So we've added all that, but we removed printf. So we would just move the result, which is the register name of the child, of the right-hand side, into the address of the left-hand side. So that's what we need to do, because this always needs to return an address. So, okay, yes, got it. So we can code gen the expression, else we can just say do some other thing, right? So either way, we're going to need to code gen the right-hand side. That's no matter what. Code gen right-hand side, right? And then we're going to say code gen the left-hand side if needed. Otherwise, store it somewhere where you would never picture. So the idea would be that in this case, right, in this case here, then this means dereference is there. Dereference is there. It will return address in results register to dereference, right? So we actually have to, or in a reassignment, if it's a dereference, we have to handle it and say, okay, we have a dereference. So we could just say if this equals dereference as well. We're going to try that. Dereference is there. It will return address in result register to then dereference. So we would like to write into that memory the result of the left hand, of the like reassignment expression. So the right hand side will be moved into the left hand side. That's how reassignments work. Wonderful. I'm just talking myself through it. I'm glad it works. So we code gen the right hand side. Then I got a phone thing, got to check out. Awesome, okay. The stream is probably going to have to end soon. I know 2 days in a row of 6-hour streams, but it's not going to last forever. So the fact that we deallocate the right-hand side means that we probably need to deallocate the left-hand side as well, because these have been used in emitted code and no longer, they can be used for other things. So if it's not a dereference, then we have to move into symbol address. So it's going to look something like this. And then This is not going to be like that. And this is going to be like this. And the symbol that we are going to use is the left-hand side symbol. Why don't I have cogen context here? Am I crazy? Symbol to address, cogen context. What is it called here? Oh, CG_context. This is why you don't abbreviate things, kids. Pog, okay. We have a variable declaration A, a reassignment. So we move 0 into racks, move racks into A. Again, optimizations to be made, but doesn't matter. Variable declaration of putter. Variable reassignment to the address of, so we load the effective address of A into racks. And then we move racks into this pointer. Oh my god, did that actually just work? Then we move 4 into racks. We then dereference the variable access putter. So accessing putter gets us this address, -40 RBP in R10. We then move from this address dereferenced. See, we move from this address dereferenced, or should, into R11. I guess we write into this address dereferenced because this is a reassignment to 4. So racks should contain 4, and we should move that into R11, which is the address. Okay, wait. Oh my god! Shell command failed with code 4. Okay, we're getting the terminal open. Oh my god. Oh boy. Yes, I know. Oh no, I broke things. You're gonna have to go away. I hate how Control D can just kill the entire terminal. It's a little killjoy sometimes. Alrighty. So we would like to run code.exe in our little funky way. Can we do that? So I would like to run this command in a do-i like this and complete it. Only works on external statements. That doesn't work. Okay. External streams. I don't even know what that means. So what we're going to have to do is then just right-click this. Oh, Christ. Can't open and for reading. Okay, so these need to be semicolons. Hey, and it works. But then we need to do the -i at the end to capture the redirection. Yeah, that didn't work for some reason. Do we need to pipe it? We do need to pipe it. Look at us. So it probably would have worked before, too. But look at us. We can now use our compiler and generate with this compile command here. We build the entire compiler from scratch every time we compile a file, right? We'll do clean first. And then we run the executable on this point file that we have open in front of us and with a verbose flag. So let's compile this file. And you see that because we have verbose, we print out the AST and the parsing context. So you can see that, for example, we have a context down here with a symbol pointer, which is a pointer to an integer, and a symbol A, which is an integer. This is looking good. I still don't know why this is printed out. We'll get to that. And then you can see a generated code at output file path code.s. So now we can go check out code.s. And as you can see, it's not too complicated. but it is actually complete because we have foo, a function. Here, let's indent. We have foo, which is a function, right? It returns at the end. And it variable declaration of A. We have a variable declaration, a reassignment. So this is a reassignment, this little part, of 0 to A. So we do that. A declaration of putter, a reassignment to the address of A to putter. And then we dereference putter and write 4 into it, which is done right here with this reassignment. We write 4 into racks, we dereference putter, which means we load the value at its address. Then we move that into, so, okay, here's what we're gonna do. I think we have a little bit of something we can fix here. We don't need to do this. We can just say that it is equal to the children's results register. So this is a destructive dereference. And we don't actually have to omit any code. Rebuild the whole compiler, compile our little pointer file again, and let's go test out our code. You now see that we no longer do that move R10, R11, and we just use R10 directly. That's much more efficient. There's no useless instructions in here. So now we have a variable access putter, which accesses putter, which is an address, into R10. And then dereference is just a variable access with specific, it's basically just an amount of pointers, right? That's all it is. We take the memory address that this points to, like this, and move it into R10. So this loads the value at R10, or the value at putter into R10. Then we move the value in racks 4 into R10 dereference. So R10 is a memory address, we dereference it, and that is now done with a variable access A right at the end so that we return A. And if we then compile with as, so we take as, input our assembly, and then generate an object file, code.o, and with our code.o, our object file, we link it into an executable, and then we run that executable in new shell, and we can see that the exit code is 4. Isn't that incredible? Isn't that incredible? This is very exciting because as soon as we get a way to allocate things, right, we're going to have a way to get a pointer to them. So right now we can create an integer, for example, on the stack, or a pointer, and we can use a pointer to point to that integer. It's so cool. So if we make another type, we can just make a pointer to that as well. It works the same way. Oh, this is so cool. And the reason this is very exciting is because it's easy to do things like this, where, this is classically where I get things wrong. So let me know if you see something. But we're going to print a long decimal number using printf because we're going to move format rip address into RCX, and then we're going to move racks into RDX. So in Windows, RCX is the first argument and RDX is the second. So we are passing printf, our format string at %LLD, and then our number 4. How about that? How about that? So in doing so, all we should have to do now is what? Let's think about this. All we have to do is run our little command, and it'll say, hey, you can't do that. LD says undefined reference to printf. So all we have to do is make it not an undefined reference, right? So what I'm going to do is do this in Emacs because it auto-completes my paths for me. So I'm going to do LD and start looking in C, and I think it's TDM, oh, it's this. Yep, and then X. And then it's like, what is it, bin? No, it's probably lib. And in lib, I'm pretty sure we just need MSVCRT, Microsoft Visual C Runtime. Still get undefined reference to printf. How does this happen? So this is why I wrote this. What did I do wrong? Chat. Does extern printf work in the assembly? It's not required. Every symbol is external. Every symbol is a weak symbol in assembly, or at least in GNU assembly. But thank you, CyberPatty. That is a great suggestion. So -L C/TDM GCC 64 x86 64 W64 and GW32/lib. So maybe it's the order. Maybe this is in the wrong spot. Has to be like up here. Where is it? It's in, yeah. Hey, that one worked. Hooray. Eat the worked, eat the worked. So now if we go to code.s and run this, sure does take longer, but we should be able to do the same thing here. C/TDM lib and then -L MSVCRT. And then we're gonna have to move it apparently. LD is very picky. We're not gonna be able to do this very well. We're just gonna move it. Yes, RIP. Lib. Nope, x86 64 MinGW lib. And then MSVCRT. We get an access denied error code. You know why? I always do this, chat. You know why? I always do this. This needs to be a Lee. Load effective address. Because this is a memory address. We're trying to move, which means we dereference the memory address. But Lee means we don't dereference the memory address. If it doesn't work now, I'm going to be embarrassed. But look, standard out. Ooh, we get 4. And we return with code 1 because that's what printf, how many bytes it wrote. Chat. Chat. Now all we have to do, I say all we have to do. Now all we have to do is make it so that external functions and symbols can be defined, right? I don't know how we're going to do that, but we're going to need to do that. As far as pointers go, we now have motherfucking pointers. We now have motherfucking pointers. Look at us. Today. Hey, it's 2:30 exactly. MFPs. Yes. TTV at CyberPatty. That's so good. MFPs. I like that. That's the name of the language. Motherfucking pointers. The name of the language is MFP. Oh, that's so funny. CyberPatty says yes. It's not a bad name. It's surprising, but it's also understandable. This we're just gonna make a child of you. And this can be like that. Hey. CyberPatty says lol, so good. Okay, we're adding that to the to-do and the naming. Name the thing. Okay. Amazing name. Motherfucking pointers. Or MFP for short. And just never implement pointers. That's the problem. We just did. Here's the problem with that one. That's so good. Oh, but we just did implement pointers. That's the problem. So, like, I agree with the sentiment, but also failed with code 4. So we are now creating a pointer, modifying it with a dereference, and we are actually changing the value of the underlying variable. And there's no get clean-fdx. Oh my god, you just scared me so much. I'm gonna go commit everything. No, no, please. No, no. Oh, Christ. We're gonna have to just do it all. There's no way we can do this in steps. Because we didn't do it in steps. Alrighty. We have pointers. This is pretty pog. This is pretty pog, I'm not gonna lie. Oh, this is so cool. Okay, so we're gonna do a celebration commit and have pointers. We actually have pointers. All the way from type checking to code gen. Amazing. Also, because we don't allow assignment to pointer unless it's a valid... Yeah, we don't allow assignment to pointer unless it's a valid... First time chat from a viewer, Sun3, with the cheer 500 that I don't have yet. Oof, I'm so sorry, Sun3. I haven't activated Twitch affiliate yet. I still have to. Cyberpatty says, flexin' them MFTs. Yeah. Because we don't allow assignment to pointer unless it's a valid pointer type, pointer return type, means you can't actually get an invalid memory address by dereferencing a pointer unless you don't initialize the pointer, in which the compiler will eventually warn. Amazing. So we have memory safety and pointers. Isn't that amazing? Pointers. That's going up. You know what we're doing now? We're going to implement some things. Cyberpatty says board putter club, yacht club. Yeah. All right. This is awesome. So let's implement some interesting math. Huh? And instead of doing it like this, let's do it in a better way. We're going to create an examples folder, and then let's do some interesting math. We also do not have a file extension yet. If you have ideas, let me know. Sun3, thank you so much for the cheer 500. I know it didn't work because I'm not affiliate yet, but I very much appreciate it. Okay, I gotta go in like 15 minutes, so we're gonna do this fast. Okay, still name the thing. Yes, here. We're gonna do a greatest common divisor. Does anybody know what the greatest common divisor is? I'm sure we've all done this in elementary, or at least we did in Merca. Is everybody familiar? Basically, you take two numbers, two integer numbers, and you try and find the highest number that divides both of them evenly. So the number with modulo equal to 0, right? That is the number we're trying to find. Mod equal to 0 on both of them. Euclid, a mathematician in ancient Greece, came up with this algorithm to calculate, given any two integer numbers, the greatest common divisor. You basically replace the larger number with the difference between the two until the two numbers are equal. So for 80 and 28, you say 80 minus 28, and you get 52 and 28. And then you just repeat and keep calling until they're equal, if that makes sense. So with 52 and 28, then we have 52 minus 28, 28. And that's 24 and 28. So now the larger number is on the other side. So we say, okay, 28 minus 24, we have 24 and 4. The larger number's on the left side, so we have 20 and 4. That continues until we get 4 and 4, which means the answer is 4. The greatest common divisor of 80 and 28 is 4. Let's implement this in our language. This will be GCD Euclid, right? So this is a function. It's going to return an integer, and it functions on two integers, a and b. It'll be funny if this doesn't work. Like, we may have problems with addressing variables, but we'll see. We'll see. So GCD Euclid of 80 and 28, we know should be 4, because I did this by hand. So obviously it's correct. No, I don't know. Hopefully it's 4. So this, upon compilation, should return the status code 4. And all we have to do is implement this simple little thing. If a is less than b, else. Right? So if a is equal to b, then return a, else, else we would like to say, hey, if a is less than b, then replace b with b minus a, right? Because if a is less than b, then we want to replace the larger number with the larger number minus the smaller number. So for an example, if a is less than b, as in 24 and 28, then we call it again with 24 and 28 minus 24. CyberPatty says you can even stop whenever the modulus is 0. No need to go all the way. True, but we don't have modulus because we don't have division yet. Return when bigger, percentage smaller equals 0. Yes, that does work. We don't have the modulus operator yet, so we're making it work with Euclid's algorithm, which uses subtraction only. CyberPatty says right. Yes, right. So in this case, we want a minus b and b. And eventually, we should get to the answer. So let's try and compile. Let's copy this and go to the terminal. So let's try and compile our example. And this would be interesting math. Oh boy, what did I do wrong? Unknown argument and. Oh, that's right. We have to use new shells separator of a semicolon. And look at that. We have GCD Euclid, which is a function. We type check it. Everything works out. Now we should be able to use our assembly builder. And we have an exit code of 4. Ironically, that's the same one as before. So let's use let's use 32 and 80, because the GCD of these should be 8, right? 8 times 4 and 8 times 10. Unless 16 goes into 80, in which case it'll be even bigger. Doesn't matter. Let's compile it, which we can do here as well. Compile it. we compile the whole compiler, I want to remind you. The entire compiler is compiled, and then the compiler compiles the file we are writing, and that's how long it takes. I just want to remind you. Then we run this assembly, generate an executable, which is linking with libc even though it doesn't need to. And then we run this executable and using new shell's little complete syntax. Exit code of 16. Alrighty. Because 16, I was right. 16 goes into 80. Which makes sense because 16 goes into 64. So if we did 88, that's not a multiple of 16. Recompile, rerun, and we get 8. Chat. It's working. It's working. So what else do we got? We did a GCD. We did it. Done did it. There's a more efficient algorithm using modulo. Here's the modulo. It's fun. CyberPatty says easy. Yes. So this modulo algorithm is actually the Euclidean algorithm. Euclid did not come up with it himself, but people over time proved that this repeated algorithm results in the same thing as this repeated algorithm. So they basically used this algorithm and tried to make it more efficient using this repeated subtraction, trying to reduce it. And that's when the Euclidean algorithm was developed. And you can see it's actually pretty easy to do by hand. There's more like multiplication to do and subtraction. And you know what I mean? Because when you're doing modulo by hand, you kind of just have to trial and error. I know there's ways, but trial and error is the closest when it comes to these small numbers. Even larger numbers. So there's also the binary GCD algorithm, which uses only subtraction and divide by 2. We don't have divide yet, and we don't have bit shift either, so we can't implement this. But all you do is effectively there's a bunch of rules. It's much more complicated, which means there's less steps, but each step is more complicated. Basically, you count the number of times that you divide by 2. So if a equals b, the result is equal to a multiplied by the result of 2 to the power of d, how many times we divided by 2. So hopefully that makes sense to you. The exponent of d, 2 to the d, is however many times we divided by 2. So this undoes all our dividing by 2. And our result is the same as above, the a equals b. So if both a and b are even, it is known that 2 is a greatest common divisor of them. So all you have to do is half both the numbers. You can divide both by 2 because they're even, and that won't change any of the greatest common divisors ever, which is awesome. So you can increment d by 1 when you do this because you divided by 2. If only one is even and one is odd, divide one of them by 2 and continue. So eventually you're looking for an end case, right? If a is odd and b is even, divide b by 2 and continue. So just divide the even numbers by 2 whenever you can. If a and b are odd, if a is less than b, exchange a and b. So make sure a is larger than b. And then c is equal to a minus b, right? So c is equal to a minus b, and c is positive and smaller than a. So a is larger than b, so c must be positive, and it must be smaller than a because of this subtraction. So, and b is non-zero. All these are non-zero integers. The two pairs, AB and BC, for some very complicated reasons, have the same common divisors. So GCD of A and B is equal to GCD of B and C. Because both A and B are odd, their difference, C, must be even. So not only is it positive, it's also even, because an odd number minus an odd number will result in an even number, which gives us a new pair to call the function again on, C over 2 and B. So that new even number, we can then use that as our new A. And that algorithm looks like this, and it's about the same amount of steps as the modulo one, but it is more efficient on a computer due to using divide by 2, which is just a bit shift. But yeah, hopefully that makes a little bit of sense. So you can see that 0, 2 to the 0 is 1, so the result is 9 times 1. All right, you can also use the least common multiple to compute the greatest common divisor. That makes sense. Alrighty, so let's implement least common multiple using greatest common divisor. Because on a computer, there's not really any other good way to do that. So let's get the least common multiple using GCD. So the least common multiple is kind of the opposite of the greatest common divisor, right? So you can calculate it using it. And I don't know if we have absolute values, but we're just going to assume that they are non-negative. So how about that? And, oh, we can't do this. We don't have division. Look, we can't do least common multiple. We don't have division. We can't do square root because we need bit shifting. And we can't do perfect square because... Hey, we can do that. Given a is the square root of n, if a times a equals n, then n is a perfect square. So we need bit shifting for square root, and for perfect square, we need square root. So we've implemented as much as we can. To do next would obviously be to implement division and bit shifting. So let's add that to the to-do. Right? We'll just do to-do, implement division. We'll do it like this, division, and what else did I just say? Bit shifting operators. Woohoo! I think that's the plan, that's the plan. All right, thank you everybody so much for watching. I am so happy with the progress we made today. We actually are like compiling pointers. Sun3 says, thank you. Of course, Sun3. RPWH_. Thank you for the follow. I very much appreciate that. I'm going to go into my little spiel at this point. So be sure to check out down below in the About section. You can see the YouTube where we have all the previous broadcasts. First time chat from new viewer, RPWH says, this looks really fun. We'll have to catch up to the progress on YouTube. There's plenty to catch up on if you check it out. Thank you. That would be amazing. That's a great idea. And this VOD will be going up right after the stream today. First time chat from a new viewer, Lambda Coder. I just got here, but I see org mode in a Lispy language. That's a follow. Hey, you know exactly what's going on, Lambda Coder. This is a very Lispy, low-level language. We just implemented pointers in the past 6 hours in our language. So this now returns 4. Here, I'll show you. We can compile it. So we use CMake to build our debug build tree, and then we clean it first. So we're going to clean, like make clean, and then make build debug, right? And then we're going to build or run. It's been 6 hours. Then we're going to run the generated debug executable with point, the file you see in front of you, as an argument, and the verbose flag. What this will do is compile it and generate a program AST, which looks sensible with a function and a function call. Looks about like what we have. And it has a list of types in the context, variables, etc. But you can see that it generates code at the output file path code.s. Code.s is an assembly file. Excuse me. You can see that if we indent it, it's a little easier to see. It has a function foo with variable declaration a and reassignment and putter and everything. That's exactly this function body. And then you can see in main, we call foo, right? Which is exactly what we do. We call foo. So, and then we just return, it returns in racks. So a, this variable access, a will be our return value from the entire function. All we have to do now is run a little magic incantation, right? Where we use as to assemble into an object file. We use LD to link into an executable. And then we can run that executable. And we get exit code 4 because A was set to 0. So for example, if we uncomment this stuff, then do our recompilation and run again, you see it now returns 0. But when we use the pointer and dereference the pointer with @, but yeah, so we have a pointer to this. Yeah, and it's all statically type checked, Lambda Coder. He says, that's great. I got interpreted pointers to work, but compiling is another level of complexity. Congrats. Thank you. And they're statically typed. So you can't do something like pointer equals 4. Look, mismatched types. Type of left-hand side and must match right-hand side. I can't speak. But you can see the left-hand side is a pointer to an integer and the right-hand side is just an integer. Hence the issues. But if we dereference it, then both sides refer to an integer and our static typing works. So now we can return, after recompilation and rerunning, 4, because 4 modifies A, because it's an address of A, so yeah. Sun3 says, just came across your YouTube channel today and started watching the first episode 001 today. That's awesome. Very amazing that in 3 weeks' time you've made so much progress. Thank you. I find assembly very difficult to learn. Your streams are very helpful. I'm so glad I can help out. If you have any specific questions, you can join the Discord down below and we have plenty of people that will help you out. We have a code review channel where we often help people out on the projects they're working on. And if you don't want to do anything public, feel free to just message me directly and I can talk to you. I'll be right back. Woo! Gotta love technical difficulties. Okay, anyway, we're back. We have pointers. Sun3 said, your streams are very helpful. Of course, right as I go to end the stream, we get a flood of people coming in. So what I will do is direct you to everything that isn't live, because I have to go right now. So, down below, there is a YouTube channel, right? Go to the YouTube channel. There are videos of this compiler being made. Each one is like 3 hours or longer, and there's 15 of them. So you have plenty of content to go watch. I really recommend it. And everybody there is really nice as well. Everybody in the comments is amazing. We have a great community, and I would love for you to be a part of it as well. CyberPatty says, thank you, Lens. Of course, anytime, CyberPatty. Along with the YouTube channel, down below we got the Discord, as I mentioned just before, where we do code review, and we have a general chat, which is a lot of fun. I gotta look at the general chat. I've missed a bunch of stuff. We welcome people in. RPWH, welcome to the Discord. Sun3, great to see you. I love to see everybody. We got Rohan in here. This is awesome. I'm so glad all of you are here. We got, hey RPWH, hello. I like the rust wave, that's funny. The crustacean. Or rustation, I should say. Yeah, be sure to join that Discord like all of you, and so many of you already have. We love having all of you in here, and it's a great time. Plus, there's announcements every time I go live, so you'll never miss a stream again. Along with the YouTube channel, there's a donate button down below in the Twitch About section. If you would be so generous and so kind and have the extra money. I don't want money you need, but if you have the extra dollar, send it my way. I will shout out your message on stream as long as it's appropriate, and if you leave your username, I'll attribute it to you. Thank you so much, everybody, for watching. We implemented pointers in a compiler that we wrote for fun today, and they actually work. So I'm happy all around. Thank you, everybody, for watching. Be sure to check out the YouTube, check out the Discord, check out everything that isn't me right now, because I have to go really badly. I'm late. Anyway, thank you, everybody, so much for coming. And I will see you next time. Maconate says thank you. Thank you, Maconate. You were so great today. Thank you for watching. Thank you for being entertained. Thank you, all of you. I will see you next time. Hearts all around. Peace, peace, peace.